All right, yeah, yesterday. So did some logistics and introduction, told you what the goals of the course were, won't rehash that. Instead, we just kicked into it. So Barry gave us a very entertaining, I'd say, history of ontology from its origins to the present day, um, with lots of wonderful jokes and ad libs that I enjoyed quite a lot. We also then Barry also regaled us with a landscape of modern ontology efforts, focusing largely on the basic formal ontology ecosystem, which we're quite fond of over at the University of Buffalo. So I then piggybacked on that and discussed various foundry efforts focusing on governance around the artifacts that have been constructed and used across the U.S. government and commercial and industry spaces as well. So because upshot there, it's not just about the precision of the ontology, the vetting of the ontology. It's also how you use it, why you use it, how you govern and disseminate information about it, what you do with it, which is something that Denise picked up on as well. So focusing from the Air Force perspective, emphasized, on the one hand, a great deal of hatred for philosophers. On the other hand, inclination to die on various hills, but some of those hills being the importance of ontology focused largely on its ROI, how you would use it in applications, what is it being used for, and you can see why. Ontology development is challenging, hard work. It better be worth it. And if it's not worth it, then why are you doing it? There are many other things you could do and many other strategies you could do for modeling data or integrating data or making things interoperable, which is where I headed in the ontology tradecraft talk. So what is it about our discipline that makes it so special? What makes it so unique? Why is it different from data modeling or writing code or machine learning? And I made the case. And again, just to remind you, if you disagree, you're wrong. This is one of those places where I will play bad cop. I do think our focus is on the two pillars of interoperability and information quality improvement. And we approach this from a perspective of systematic disambiguation. And we use things, our artifacts like top-level ontology, basic formal ontologies to spell out those disambiguating options, the logical space of interpretation of data so that we can improve data quality, information quality, while also integrating our data with other data sets that we haven't thought of and might not be thinking of at all. So after that, we shifted over into exercises. So I wanted you guys to get familiar a little bit with Protege again, as I said, and I'll repeat, not my favorite tool, certainly not one I would use in production ever. You shouldn't, don't. You can tell Mark I said that. Also, Mark Musen, yeah, not Jensen. I think Jensen would agree. But it is a very useful pedagogy tool, so useful for education, helpful for seeing the structure of ontologies in small use cases like the one I had you work through. And in that exercise, I had you create triples, or I seeded some triples. You move them around in the interface, and then you used a reasoner to see if certain claims followed from your commitments. And then I had you break those commitments to see if it still followed, and it didn't if you did it right. And then I had you add them back to see if it didn't fit again. And this is how reasoning works, and this is kind of what we're doing. As was pointed out in the Q&A, you can think of it in terms of constraining logical space of interpretations and possibilities. The more axioms you add, the more you constrain the space of interpretations. The more you constrain the space of interpretations, the more you can infer. And that's kind of the name of the game. I talked with Jeremy Ravenel, for what it's worth, last night after I left, and I came up with this very interesting set of exercises he's going to walk you through on Thursday that highlights both the difference between abductive reasoning and deductive reasoning by building up basically the answer to a very well-known puzzle. It's Einstein's puzzle, which you can solve deductively. But if you remove some axioms, then you can generate, with agents' help, as he'll show you, some abductive best candidate explanations for the answer, even when you remove premises. So he'll walk you through that. I'm pretty excited. I just wanted to foot stop because it was my idea. Anyway, and with that, I have nothing else to say about what we're going to do. Or what we have done. I'd rather instead talk about what we'll be doing today. So we're in the orientation. Welcome. Hi. I'm going to kick us off today by focusing on a rather challenging modeling topic, modeling unreal things, stuff that like unicorns or Harry Potter or Harvey Potter, if you're me and you like making fun of people. And Barry is going to discuss with some colleagues another very challenging modeling topic, the law. Yeah, I see some smiles. It can be quite challenging. So, and then after that, we're going to have a discussion also led by Barry over modeling systems. So systems, a hot topic, comes up all over the place. Everybody seems to know what a system is, and yet nobody seems to know what a system is. And so you'll hear a lot more about that, and also learn by watching the wisdom of Barry. Will be here on display, showing you his wares and how he thinks through very challenging problems with other people. There's going to be a lot of helpful insights to glean from that exercise. So I encourage you to pay very close attention to the debate, the discussions that come up in those conversations. Afterwards, around 2 o'clock, we're going to hop into exercises. I'm fiddling with some of them now. Some of them will be very challenging modeling exercises, building on what we did last time, but also building on the talk I'm about to give. And then Barry's also going to, or Barry has some definition exercises too that we'll add to the mix. So we'll be focusing not just on modeling, but making sure you know what you're modeling when you're talking about various terms, and they'll have associated definitions. You'll find that it's quite challenging to come up with good definitions. And you also find there are criteria for determining what good definitions are. Surprise. After that, we will have a debate. So Barry and I will be discussing some topic. Please do go to the day 2 discussion board and make a suggestion as the day progresses on what debate topics you'd like us to discuss. We have a couple in mind. If you don't give us anything good, we will say so and then just pick something else. We do have the AI stuff we could chat about. I think we probably will. But in any event, maybe you'll have something better. So give us your ideas, your best candidate debate topics, and we'll go for it. That, how am I doing on time? Perfect. So, yeah, I guess I segued in right quite nicely to debate topics and anticipated myself. So I will pause here because I have 5 minutes on the agenda and I'm a stickler. Any questions, comments, concerns, etc.? Or I could just get into it. Claire has a question. Yes, Claire.
Be doing presentations on things assigned at the beginning of the week, but now on day 2. I was wondering if we were going to get assigned things.
Beginning is loose. Beginning is loose. We're still in beginning. We're gonna give them to you today. I just forgot. Just be candid. I was busy editing the video. That's right. No. Good. Great question. So Claire is asking about student presentations. So the enrolled students will be given presentations at the end of the week. And as astutely noted, we will be assigning those topics because we want to make sure that you present on something worthwhile.
And that means enrolled students.
Enrolled students
in this room.
Not necessarily, that doesn't necessarily overlap with students in this room. It doesn't necessarily overlap with everybody attending. It's the ones who have formally gone through the process of enrolling at UB for credit. So if you're enrolled for credit, you'll be given a presentation. It doesn't have to be recorded. Doesn't necessarily have to be recorded. We're going to work on it. Say that again. So we'll give you a topic. We're going to give you a topic.
Negotiate.
Negotiate. Well, we'll see.
I mean, I can talk about what are we doing today?
I mean, that's a great idea.
I mean,
What a great idea.
If you want to update, I mean,
Yeah, it's at the winning. We got time. Are there any other questions? No, thank you. I appreciate it. I would have forgotten. Yes, go ahead.
Yeah, good morning.
Good morning.
I saw your slide from yesterday where you were trying to distinguish, I guess, between an ontology and a semantic layer. And I wonder if you can shed more light on that, because I feel like perhaps a semantic layer will translate what's in an ontology for broader access.
Oh, I
But
love
I just
that.
want to clarify
No,
my
absolutely.
thinking.
So I gave some high level, it was just largely the point I was drawing was to distinguish between the semantic layer and operational layer, but I didn't say much other than talking about authoritative semantics living in the semantic layer around what a semantic layer was. I think that did come out later in conversation with Denise, was talking about the kind of broader ecosystem or the broader kind of architecture around semantic layers, and I agree 100% with what she was saying. So, and what you're saying here as well. So it's not just an ontology, it's not just maybe knowledge graphs, ontology connected up with data. It's also how that information is disseminated to applications. So there's like there are workflows that go on as emerging from a semantic layer into operational layer that have to be governed. And so I consider that part of the architecture of a semantic layer. And so you kind of saw me gesturing at this when I talked about conservative extensions or derivations or derived products from a semantic layer. I wouldn't want to trust, say, an organization or a contractor who is creating an application with just using an ontology and then assume they are preserving the semantics the way I think they should in their application. So there needs to be not just governance around what this a reference set of ontologies or authoritative semantics is, but also how it's disseminated in applications. So that is correct. I
Thank you.
don't have, unfortunately, too much time to continue on, but I will try to hit on that a couple more times. But I've got some engineering meat to add here and there. I'll pepper throughout.
Thank you.
Perfect. Awesome. Okay. So, guys, I'm going to push over now into one of my favorite things to talk about, stuff that's not real. Although I don't consider myself too much of a philosopher anymore, this is about as philosophical as I'm going to only in the topic. It's still an engineering project as far as I'm concerned. So what am I talking about here? Well, first, let me set some stage. So should think about the problem set I'm about to discuss, the case I'm about to discuss in terms of realism. So this is a methodological conviction of basic formal ontology. Although the problem, as you'll see, is bigger than BFO. It actually stems partly because of OWL, the web ontology language we encode our ontologies in. And so, but just for stage setting, it's not inappropriate to pitch this initially, at least for stage set in terms of realism. So I think of ontology engineering strategies as distinguishable around directions of fit. You could think of, at least in part, you can think of this as like world to word, where you try to make the world fit your words, or word to world, where you try to make the words fit the world. Suppose, just to get a handle on this, suppose you're a spy watching someone shop in a grocery store. They have a shopping list and they're checking items off as they put them in their baskets. And suppose this spy's list directs him to buy butter, but you observe that this gentleman buys margarine instead. What a loser. Now, suppose you're aiming to align his behavior with the guidance on the shopping list. And one way you could hold him up and say, hey, buy butter and replace it, coerce him or something. Another way you could get this to happen is you could have him, or you could erase your description, or I'm sorry, the description on the list, that shopping list he has. You could erase butter and replace it with margarine. Now, in that way, since he's already bought the margarine, you've made the words on the list align with his behavior, so you've synchronized them. On the other hand, suppose instead you're aiming to record his behavior as accurately as possible. One way you could do that would just be to record as you did the divergence. So you keep the list that he's working with as it is, and you just write down what he's done. That there was something on the list that he should have bought that he didn't, and that you were recording what he did. So I think of these directions of fit as carving up different kind of approaches to ontology engineering strategies. So there's this conceptualist bent in ontology engineering. Dolce is an example of a conceptualist architecture. You think of them as modeling language or concepts, our best case understanding of how the world presumably is supposed to be, but it's focused largely on concepts, what we think about things. And we try to fit the concepts. We're focused largely on the concepts in our understanding rather than kind of the world out there, that external arbiter. And so there's fitting of changing of words, manipulating words here and there, as words often are manipulated by conventions and shift and change. And instead of thinking about maybe privilege or in better or worse ways of understanding words in terms of what they're supposed to be about. So the conceptualist is to my mind, the direction of fit that goes word to word. And the realist camp, the one that Barry and I advocate for, is the word to world camp. We are trying to accurately describe what's going on. we are not beholden to language so much or concepts. We model the language and the concepts because that's part of the world, but we don't stop there and we don't even focus there. We focus on the arbiter that is the world. So I'm hammering this down because if you've heard about ontologies, you've probably heard them described as, from Gruber's characterization, an ontology being a specification of a conceptualization. This is a very famous characterization of ontologies. It's very influential, and it's often interpreted as claiming that ontologies represent concepts. You see conceptualization right there. A couple of things to point out. One, that is a misreading of Gruber. If you read Gruber and then you go read the citation that Gruber is using, it's for a conceptualization notion that is in an AI and logic textbook. And the AI and logic textbook defines a conceptualization as something that's about the world. So if you just follow the through line, he was not talking about concepts at all. Although you will regularly see in literature and talks, people cite this as an example or a reason to think that ontology should be best understood as about concepts. They just didn't do their homework. Gruber never even said that. He then followed up later, this is another point, by taking a more pragmatic view and said one can say that ontology is a tool and a product of engineering defined by its use. I put this in here to kind of focus in on that, what I was talking about the other day, but the semantic versus operational layer. I think here, in this second characterization, there's a conflation that's going on in ontologies and what you're doing with them. So ontologies aren't defined by their use. They're informed by their use, but the operational layer is separate from the authoritative semantic layer. Meanings aren't determined by their use. They can be informed and influenced, but they are separate things. One's in a semantic layer, the other is an operational layer. So take that, Gruber. But all that aside, the barbs aside, ontologies are specifications of the world. That's how we understand them. And part of the reason is because we're interested in the world. We're interested in that arbiter out there outside of our concepts or practical or pragmatic considerations. But the other is a practical upshot. So there are exercises, easy to construct. I won't do it here because I have a different beast in mind for today, but it's easy to generate, or like the reasoning why you would want to have something like the world as an arbiter. If I asked you to construct, for example, a definition of beach, like a sandy beach, and I asked you all to do that, you would all come up with slightly different definitions. Like no joke, or target, or building, or facility, over and over and over again. Part of this is because as a practical exercise, if I asked you to do this, you're going to be thinking about what you think about beaches. Now, if I tell you, and this is an exercise I've worked through several times with students, if I tell you instead, hey, I need you to focus on what buildings really are. What's the nature of buildings? What's the essence of buildings? If I use some philosophical jargon, I wouldn't do that in an exercise, but just for speed here, you would start thinking not just about what you thought beaches were, but what you might defend to somebody else about what beaches are, about the world. You need an external arbiter, and you'd have that external arbiter that you would be pointing to, the real world. And this is what a beach is. Now, of course, it's a challenging topic. Where do beaches end? I don't know. Fractals. I don't know. But nevertheless, you'd be thinking instead about what you thought and more about the world. This is an empirical claim I'm making for what it's worth. It's one that I've seen again and again bear out. It's one that I use when I talk about realism. I'm like, you're talking about the world, think about the world. And in fact, I'll highlight that yesterday's exercise in here, we had a question come up about where to put moving patrol boat. Should it be a subclass of patrol boat, or should it be a subclass of material entity, or should it be a process? What is the nature of moving patrol boat? Should it first be a material thing that moves, or should it first be something that moves that is a material thing? All right, I'll let you ponder. I'm going to move on. Information and aboutness. Yeah, we know the answer now. We worked through it. Okay, information and aboutness. So we are disposed to recognize patterns with our faculties. As you can see here, there are 6 images of my mom. Pause for joke.
That's a very funny joke.
Did you say it wasn't? I don't think so. You're wrong. So we do this all the time, like crystallography, photo 51, DNA, and helix and whatnot. We see these patterns all over the place. We're disposed to recognize such things. Some patterns are about things, and some patterns aren't. Snow is white expresses content that's about snow, putatively. That centimeter, a little CM right there, or the period, or a period that's not at the end of a sentence, those are patterns, but they're not necessarily about anything. Now, of course, you usually see a period at the end of a sentence. And so in that broader context, yeah, there's a pattern. Maybe it's about something, stopping a sentence, but just on its own right there, it's not about anything. Most patterns of interest to ontologists are about something. And we characterize them with this relation, a primitive relationship between information, which is a subclass of generically dependent continuants in BFO, information content entities. And information content entities are generically dependent continuants that are about something. So you have this is about relationship, a primitive relationship between an ICE and some entity, entity being the top class in BFO. So something. Information content entities can be about anything. Remember last time I walked you through the 7 steps when you're modeling competency questions, and I left information at the end. And I told you I leave it at the end on purpose because if you don't do it last, you'll confuse it with something else. It's because information can be about anything. And so you'll often find yourself getting up into tizzies over whether you're talking about information or qualities or realizables or information. And if you don't save it for last, you have a tendency to confuse those things. So save it for last. Because it can be about anything, like measures of independent continuants, for example, temperatures of an apple, or inches. So this is a common core ontologies measurement pattern. You've got an object that has a quality that you want to measure. It's measured by some information content entity that adheres in some bearer with an associated unit and some associated value. You can also measure other information content entities, or you can have patterns or information content entities that are about other information content entities, just like you can have GDCs or generically dependent continuants that can be about other generically dependent continuants. In this case, we have the concretization in an ink inscription of Beethoven's Ninth Symphony as an information content entity. We spell out this relationship. Beethoven's Ninth is an instance of an information content entity. We say it's concretized in the qualities on that parchment there that you see represented on the screen, the ink inscription. And then that ink inscription, the quality, the ink, adheres in the parchment, which is a material entity. And then Beethoven's Ninth, we say generically depends on that material entity bearer, which is the parchment. And also, Beethoven's Ninth is about some plan, an orchestral plan that is an information content entity. And musicians have plans that go into this, and they are dispositions that adhere in the brains or the cognitive architectures of these musicians, and they are realized in the performance of Beethoven's Ninth. Look at all that complexity. There's a triangle, Beethoven's Ninth. This is, by the way, I know some of you are going to object because somebody always does. This is just one way of understanding Beethoven's Ninth. Let's not get tripped up over the words. But observe, there's Beethoven's Ninth that's concretized in ink inscriptions that adhere in a parchment. Beethoven's Ninth there generically depends on the parchment. It is about some orchestral plan. That's the part you're probably going to want to push me on. Beethoven's Ninth is about an orchestral plan, the concretization of which is in the brains of these individuals.
They use their arms and their lips.
Yeah, of course, of course. This is granular. I'm just trying to give them the high-level design pattern. And these things, when properly trained, the musicians, of course, training is involved. Once they've trained correctly or trained enough to build up the appropriate dispositions and skills to perform the piece well enough, they'll have the realization of the performance of Beethoven's Ninth. Broadly speaking, this is how information works. But note, this is all real stuff. All real stuff. There are instances, there are people, dispositions that they have, skills. There's parchment, there's material stuff, there's ink inscriptions. I told you, though, today we're going to talk about not real stuff. Just wanted you to have the background. Now think about this. So we are realists. We talk about the real world, right? That's our arbiter. And we can also talk about information. Information that is generically dependent continuous work that is about something. It's got to be about something real, right? Because we're realists. Here's some tricky cases. Sam claims that Superman is strong. Some is strong. Dang. Stong. You know, I was moving fast. Blueprint. Samantha creates a blueprint for an Airbus 320N. More simulation. Cybersecurity experts create red team exercise. It's like 61626, whatever that is. What are these about? So in a simulation, you're hoping this doesn't happen, right? You're trying to simulate for a counter, like a red team exercise. You hope this doesn't happen. Some state of affairs does not manifest. When blueprints, you might create a blueprint for something that is never realized. You never see the Airbus 320N. You've got a spec for it. What's it about? Fiction. I mean, there is no Superman. What's it about? What's it about? He suggests there's something that a given expression is about. Superman is strong with an R. For example, one way of understanding this expression, though, is in terms of concepts. Of course, we're looking for something deeper. This also doesn't seem to do justice to what Superman, or what sense of Superman is at play. Is it just what I think Superman is? Is that what Superman is? Is it just what John thinks? Superman refers not simply to the concept of Superman or mine, yours, anyone's, but something they have in common. So realism, understood in this context, means that information must ultimately be about real entities. But there's no instance of Superman, no instance that the Airbus spec would be about in this characterization. There could be, of course, you could create the Airbus 320N according to the spec, and then you've got an instance. But before that, no such instance. And hopefully there's no cyber simulation 626 instance. Hopefully that simulation never is realized. But these are clearly important cases we need to represent. So how do we do this? To satisfy realism must correspond to some individual in the world. For an instance to satisfy realism, that is, and for a class to satisfy realism, there must be one or more instances falling under it. So a real class, as I'm talking here, is one that has instances, like a river, like the class river and class mammal. We're all mammals. We've seen rivers. They exist. They're instances. Since there are no instances beyond the concepts in our three problem cases, we have to find a way to work through real classes. That's the insight here. And I'll also note that this is a little bigger, as I pointed out, a little bigger than just a realism commitment. So it's partly due to the constraints in OWL. So OWL is the language that we use to encode our ontologies in. It requires that we can only form relationships like is about or located in or parthood between individuals or instances. So you can't assert relationships between classes or instances to classes in OWL. You can in other like more sophisticated flavors of OWL, like OWL full, but those are undecidable. And if you want to know more about the logic around that, I'm happy to. But for our purposes here, we were restricted to talking about instance to instance relationships, but there is no Superman instance. There is no cybersecurity simulation 626 instance. How can there be something about it? Right? There's no hook in OWL that we need. All right, so problem set up, lots of fun jokes, misspellings, and we'll move on. Talk about the unreal. There is a way, though, in OWL to address this problem in a way that aligns with realism. So we do have the resources based on the logic of OWL to relate relevant information to logical combinations of types of classes, which is the key, without commitment to there being a specific instance of the intersection of the combination of classes. And these combinations of classes can be decomposable into real classes satisfying realism. Now, this is a lot of jargon for you. So I will walk through several examples because there's a recipe. And it's just this. We model statements of the sort like Superman is strong or strong as information content entities that are about the logical combinations, i.e., the intersections, the unions, the negations of, etc., real classes. So if you remember discussing very briefly in OWL, I told you OWL provides a logical vocabulary and very minimal logical vocabulary to union classes together, to say that they're disjoint, to talk about when something's not something else. So you can combine classes under this OWL formalism to like kind of isolate what your statement about Superman should be about, even though it's not about anything that actually exists. And we can leverage the Common Core ontologies to provide different sub-properties or sub-relations of is about to distinguish fiction from blueprints from simulations. And we use describes, prescribes, and represents. So in CCO, you'll see these. These are relationships that already exist. They've been widely used for many years. Although some of the definitions I take issue with, but for our purposes here, I will take that hat off and talk about describes. Describing for fiction. Describes is a relation that holds between information content entities and some other things, such that the ICE is about the characteristics by which the entity can be recognized or visualized. This is fiction. You can recognize Superman. There are certain characteristics of Superman. Now, what those characteristics are, we'll talk about in a second. I'm just highlighting the relationship. Fiction as distinct from prescription. Prescription is the next one. This one holds between information content entity and some entity such that the ICE serves as a rule or guide for that entity. And in specific, if the entity is an occurrent, that serves as a rule or guide. And if it is a continuant, it's a model for it. So like a specification, for example. And then representation has a lot of jargon about isomorphisms that I won't get into. This is kind of the miscellaneous class. This is the one we say for cybersecurity. This is not describing anything that you would visually recognize or recognize cognitively. It's not prescribing the way things should be, but it is representing something, broadly speaking. The more interesting part is the recipe itself. So here's how it works. You want to represent Superman. You introduce an information content entity, and then you identify classes and object properties reflecting the intended meanings of that information content entity, such as super strength or part of or so on. And then you assert that that information content entity is about only, that's important, only a class equivalent to the logical combination of classes and restrictions on object properties, where you focus on fiction being descriptive, blueprints being prescriptive, and simulations representative. And then for any class or a lot of object properties or relations constituting C that don't have instances, you return to the second step and decompose according to the method. Don't worry, you don't have to write it down. I'm going to give you examples. Samantha drafts a jet specification blueprint for an Airbus 320N, attaching various model and manufacturing information, as well as requiring it to be fixed wing, have exactly 2 engines, Airbus being a manufacturer, etc. So the scenario here that I'm thinking about is one in which there is no Airbus 320N that's been manufactured. This is just a specification of what one would be if it were. Now, of course, later they might roll one out, and then you have an instance that the specification is about. But up until that point, there's nothing. So what is this specification about before that rollout is the question. Here you go. It's a jet specification. It's information content entity in this model is just a generically dependent continuant. It's fine. There's an instance, Airbus 320N spec, that is an instance of the jet specification. And that Airbus 320N spec is about only, in this case, it would be prescribes only, but in more general cases is about only something that has continuant part, exactly 2 engine, is a subclass of fixed wing, and has a manufacturer Airbus. The only there is doing a lot of work. Airbus 320 is about only the class C defined as equivalent to the intersection of all of that stuff in the box. In OWL, you can introduce what's called an anonymous class. Anytime you introduce a logical connective like only or some, you introduce what's called an anonymous class. It's not a class that's named in your ontology. It doesn't get a name. It holds, though, a bunch of properties that hang off of it because it's in RDF, everything has to be in triple form. So if you have like, I didn't even draw a circle there. I have an arrow pointing to a box, but where those three arrows are popping off of, implicitly there is a class there. And the Airbus 320N spec is about only things equivalent to that class. Again, the only is important because what this says is if Airbus 320 in spec 1 is about anything, it's about something that falls in that class. It's not committing you to there being something. There's another way of characterizing this using the logical value. You could say it's about some or something that has jet engine, fixed wing Airbus. That would be a mistake because there is no such thing. If you used some, you would be asserting that there is something there, but we are not doing that. We are saying if there were such a thing, it would have all of these features. When I talk about the intersection of classes, it's in that box. That is the intersection, the logical combination of various classes that define an anonymous class, such that if there was an Airbus 320N that was modeled according to that spec, it would be an instance of that class. Now, you'll see later when you walk through exactly this exercise and you have much more complicated things to say. You can just represent this directly in OWL. You could represent this directly in Protege even. It's a little complicated. So if you look down or look here, if you see in the class, in the individual bucket there, you can introduce an Airbus 320 in spec 1 as an instance or an individual. And then you can pop over to that lower right-hand box where it says types. Usually so far, if you've been playing around, you say, oh, I'll see a class hierarchy and I'll say, Airbus 320 in spec is a type of like spec or jet specification or GDC. And that's all you'll put there. Turns out you can put a lot more logic there. You can just type out all the logic you want that hangs right on the class or the individual. These are individual restrictions. And you can say it is about something. See that only there, an anonymous class. It's embedded. That parenthesis there introduces an anonymous class. Only things that are fixed wing, have continuous parts exactly 2. Looks like I forgot to put 2 engines. And has model FAA value, some Airbus 320 Neo has model BADA value, Airbus 320N, blah, 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 blah. You can just spell out the logical combination of things you believe characterize this specific spec. Combination, ands, onlys, exactlys, value, those are reserved vocabulary that are part of OWL. That's logic. Only introduces an if, then this, and introduces a union. Value introduces a literal. Don't worry, you're gonna get more practice. So highlighting the recipe though. What about Superman? Because it works for Superman as well. It's probably easier to understand with Superman. I like the harder stuff first. So fictional description, Superman, the expression Superman, instance of a fictional description, you can say, which is an information content entity, we'll say, and describes only something that fits the following intersection of classes, such that they're described by some Superman comic, bearer of some super strength, that has origins, value, Krypton, fires eye lasers, some laser, stuff like that. Now you're probably thinking, wait, hold up. You just introduced a bunch of things that aren't real. Krypton's not real. You put Krypton in the recipe. Nobody fires eye lasers. Come on, John. You're just smuggling things in. No. You just run the recipe back. You run it through for anything that doesn't have real instances. So Krypton, there is no real instance of Krypton, but is an instance of a fictional description like Superman and describes only what? some astronomical entity, the bearer of some rocky quality. I don't know much about Krypton, but you spell out whatever the characterization is, and you use that only logic and say, if there were anything that satisfied all of these commitments, all of these constraints, it would be Krypton. That's how you do it. Same for fires eye lasers. So this is a relationship. X fires eye lasers Y, if and only if. You've got some person, presumably, who has part something that's an eye that bears a laser firing disposition, and Y is an instance of laser. So observe their eye, person, laser, laser firing disposition. These are all classes that have instances. There are persons, there are eyes, there are laser firing dispositions. Machines do this. We build machines that fire lasers, and there are lasers. So I've decomposed this fires eye lasers relationship into classes that have instances. So I'm committed to realism, and this is fun. I've decomposed them into real things, even though it fires eye lasers itself, there is nobody fires eye lasers. Not yet. I'm working on it. Same with Krypton. So red team simulation. Instance of a cyber war game simulation representation. It represents only such things that have these features. This is a little more complicated. I mean, there are ellipses at the ends of all of these. You can go on and on and on. So, but I just wanted to highlight cyberattack process, has participants some U.S. Army, has participants some adversary. I'm spelling out things that have either are instances in the real world, like the U.S. Army, or have instances like adversary or active targeting. You just decompose anything that seems putatively unreal into things that are real. That's just, in this case, done from the instance level to a class that may or may not have any instances in the intersection. Harry Potter is not real. He's not. Harry Potter's not real, but we can talk about Harry and we can describe it, and we can get really thorough describing. Well, we can get really
If there
thorough.
is no Harry Potter, we can't talk about it.
Absolutely, we can. That's a mistake. So we can we're talking about him now. But listen, here's how it works. Harry Potter's not a thing. There's no instance of Harry. And what does that mean? Is there's an intersection of all these properties. He's got like a scar on his head. He fires lasers out of his hands. I don't watch the movies. I don't know. But he does a lot
You're
of
trying
things.
to have your cake and eat.
I'm having it both. But listen, we can talk about that at the class level. All of those classes, and we have descriptions that are about the anonymous class. It's just that there is no instance at the intersection of all those classes. That's it.
Can I?
I think hold on, just saying, and then we'll do. So I'm saying proper understanding of fiction, simulation, and blueprints favors interpretations in which relevant information is a logical combination of types, and combining this with realism, we maintain the target of relevant information is ultimately real types, and there's a recipe that fits with OWL for doing that. Oh yeah, I'll just say this was placed here for a reason because later you're going to be doing this. And also I want you to keep this modeling in mind, both the realism commitment, information commitment, various design patterns that were worked through about unreal things. While Barry is discussing the law, while Barry's discussing systems, there's unreal stuff all over the place. Keep an eye out for it. But also more importantly, even if you're going to disagree, separating information from what it's about is crucial in all of these conversations because the law is a lot about information systems, have information language all throughout too. And we'll revisit this topic later when we're having you design actual design patterns around this model and encode them in OWL. All right.
So I agree with you. In fact, I think I take an even stronger line on realism than you do because you tend to be sloppy at various points when you
was that
when you talk about they think about Sherlock Holmes. If there is no Sherlock Holmes, then you can't think about Sherlock Holmes. Now, what's missing from your account is the following. From very early on in the evolution of mankind, we had to develop skills of thinking about bad guys, bad forces in the jungle. And so we have, I don't know whether it's a special part of the brain or a special set of skills, it doesn't really matter. We have a capability to to think about and to talk about with our fellow members of the tribe what are in the end not entities. Sorry, it's very hard to say this. What is in the end not there, may in the end doesn't exist. And this becomes more and more sophisticated over the generations. So now we have novels, and people are sophisticated in making novels which are about nothing seem to be about something. But it's this seem to be that you forget. So we have this clever ability to make noises in the jungle seem to be noises of invaders from the next tribe. That doesn't mean that there are in any sense invaders in the next tribe that we are afraid of. And it doesn't mean that there is in any sense Harry Potter. We cannot think about Harry Potter because there is no Harry Potter.
What am I thinking about when I say Harry Potter shoots lasers out of his wand?
So this is where you and I agree. There is some class of the entities which are only named Harry.
Yeah, only describe only something that is like this that doesn't
and
exist.
has name Harry and so forth. So that on the class level you're okay, but you keep jumping down to the as does
Oh, but I'm
everyone
not.
else.
I'm not. Oh, I'm absolutely not. Like I stop. So the instances I'm talking about are like the specification or like an expression or the content of an expression of Superman is strong. It's like a language level. Or if we want like the quality
okay,
level.
but still there's something missing from your account because
yeah.
if you draw it on the screen with these symbolisms, this is not getting close to what's going on in people's brains when
That is true.
when they
I
read
think
novels.
I think this is meant to be a supplement or a supplemented view. So I'm not talking about cognitive processing. I'm not talking about what's like the qualities and the hearing in the brain. I've thought a lot about attitudes and relations and whatnot, but this is compatible with a cognitive view where you're bearing attitudes towards propositions or prescriptions.
All right, so let me now
Mm-hmm.
try one more line. So let's suppose you're an intelligence agent and you've been told to look for somebody called Khalid bin Laden because there's this rumor that
It's a great combination of names.
Khalid was in
Sounds
fact
dangerous.
the real boss of the 9/11 team. So your job now is to look for Khalid bin Laden. There is no Khalid bin Laden, but your job
I'm gonna find him.
is to look for him. And now you collect lots and lots of information which seems to point in that direction. And you join it together in your mind as information about one person. And now there is no such one person, but you have created this story which suggests that there isn't. You're collecting more and more information. Maybe you have a group of people in your unit who follow you and they're collecting even more information.
That's right.
Now, what in your class-based account accounts for the fact, which isn't a fact, accounts for the pseudo-fact that they all think that they're searching for the same individual? Go on.
I mean, I think so. This is a great case, but I think it's one that fits right in the class in the account, right? So there is like playing a game of Clue, a combination that's added to intersection of classes. These properties here at this location, this I'm pinging on this phone, this network, blah blah blah, and I see advices or instruction given from this area to these people.
When Agent 1 says to Agent 2, look, he's entering that building, where they see a kind of squidge on a nip video, they're not. They're talking about. I don't know.
If an agent is saying, look, there he is.
Yeah.
And there is no such guy. And he's pointing to this fellow over there. There's clearly a disconnect between the intersection, like what they know, the evidentiary profile, and like what's going on there. And there's a belief or an assessment that there is an instance that falls into that
Okay, good,
intersection. And
good.
they've made, but this is like a meta thing. They're making an
Yeah,
assessment or
I
a
think this
judgment about.
meta thing may be what you're missing. So,
Oh yeah, I agree.
yeah, good. All right, then we'll
Mhm.
stop
Yeah, yeah.
arguing.
And I do have work on, no, I don't think this is an argument. I think this is very helpful. I do have a lot of work, I just haven't published it, on like the cognitive aspect of this, where there are confidences or credences associated with assessments of evidentiary
Okay.
profiles that fit right in here. And it's different from David's because he's wrong.
Which David?
Look,
Ah,
I'm always giving him crap. But it is born out of this cognitive model of like an agent or an individual is bearing some relationship to some information content, and like whether it's prescriptive or descriptive or whatnot. And then there's in a sense, there's like judgments about beliefs, judgments about desires, there's assessments and confidence intervals that are associated or not. It gets a little complicated, but not that complicated. We've got hands in here. I'm not sure whose hand was first, so I'm going to go in reverse order because I saw Bill pop up and he came in last. So Luke. Might have to unmute
Sorry,
yourself.
yeah, I got it unmuted. Sorry about that. I just wanted to know how your model or how this works with instances or multiple instances. So like Superman, it makes sense because there's just one guy, Superman, but like you could presumably have multiple planes. And so I'm just curious how it seems like when you're talking like that, when you're talking about something that doesn't exist, it's appealing to just one thing. But if that one thing could then exist later as multiple things, like how does that work, I guess?
The model would work, well, here, I'll carve two cases so that we can decompose. But I will point out that the Superman example itself already has multiple instances that aren't real. Krypton's not real. And so there's a recursive recipe here. So you go back, if you find something unreal, you do it again until you decompose it. But there are two ways to understand your question. One is just that you've got multiple things, they're all unreal, or they don't have instances associated. You follow the pattern, you follow the recipe. Whether they're embedded within a description of a description or not, or a prescription or a representation or not, or whether there's some combination of a description that has a prescription as part of its explanation or characterization, run the recipe recursively again. That's one way. The other is if you're talking about like aggregates of things, like aggregates of Superman, or like the Justice League. I don't know why I use this example. I don't even read DC. I'm a Marvel guy. But we'll stick with it. You like Aquaman, you're wrong, but whatever. Justice League. You got a bunch of individuals that are members of this league of extraordinary superheroes or whatever. Again, I don't read DC, but you've got them, none of them are real. The group is not real. You run the recipe again. You can do it at the group level. Now, part of the characterization of the Justice League group is presumably that it has certain members. It has like a Superman member. And then you run the recipe again on Superman. They like fight Martian Manhunter, a supervillain, some supervillain, Lex Luthor. I should have picked that one off the top. Stuff like that. But again, it's just a recursive application again and again, whether it's for aggregates of things collected together in a description or individual pieces, you just kind of break it down to its or decompose it into its real parts.
Okay, that makes sense. I think that I was more asking though, like what happens, like how does it work once you have an instance, right? So not something purely fictional, but something more along the lines of like the airplane example, where presumably you could make more than one airplane.
Absolutely.
And so how does it pick up on like when, say I make 3 airplanes or 2 airplanes, simpler, what changes, like how does the system, like what changes within the system when that happens?
So if you've created your Airbus 320N instance, and you've got several of them, they're rolling off the assembly line as they tend to do. Rolling all these things off, you have a specification of that. You have the blueprint, and the blueprint is about all of them. It's about the first one, it's about the second one, it's about the third one. It's the model, it's the guide for how you're constructing it. So nothing changes. You follow the recipe, you decompose it. So what you have though is a separation, and this is important. You have the separation between the specification that is about the intersection of a bunch of classes that may or may not have an instance. And then once you start rolling off instances, they are instances of that anonymous class. And that's fine. There's nothing wrong with that. That's just a clear separation between information and what it's about. Now, you're describing a case in which you've actually created the thing that your specification is about. Now, you're not going to get a case like that with Harry. We're not going to put Harry Potter together. One of the reasons is different from the prescription case. Like, we're prescribing as a guide to do something. Of course, you can prescribe impossible things, in which case you just have the collection or intersection of instances or classes that have or never will have an instance, like a square triangle. We got a question real quick, and then we'll hop over to Alec and Sarah.
Do conceptual-based ontologies have examples of things that don't exist? Because I feel like you could point to a concept of anything and say, well, yeah, like there isn't a Greek god in the sky causing rain necessarily, but there's a concept of something causing rain, so that's kind of like Zeus. So yeah,
it's in there. Does Dolce deal with stuff like Zeus?
Yeah, but there are probably infinitely many Zeuses.
Oh, of course.
Let me try and answer this one. So that's precisely what is wrong with concept-based or conceptualization-based approaches to ontology. They mix the level of concepts with the level of things in the world, and they can draw on that. They think it's a clever technique, but in fact it's a mistake. And so there are concepts, of course, in people's heads. You can teach people concepts. Psychology, there is a branch of psychology called conceptual psychology. But for years, I would go around the world getting angry when people used the word concept, because most of the time in ontology, they were using it badly, because they thought that ontologies were about concepts. And I'd succeeded. I mean, now in many circles, people, they hesitate. They say, yeah, idea or something, because of this period. But now we have to work out how we deal with those kinds of problems, which seem to be solved if you have concepts up your sleeve as objects in the world that, for instance, live in Moscow. They really made a very silly mistake. And as he said, Gruber, who is usually pointed to as the victim or the author of this silly mistake, didn't make that mistake.
No. We certainly interpret it as it's just because they didn't do their homework. Alec and Sarah.
Yep. Thank you for the presentation. My question is that when you talk about, let's say, the sentences and statements or like a specific specification, isn't it more than like a just bunch of entities we are binding with the end, but like a configuration? I'm basically referencing to the 2015 paper that are talking about the information content is actually about configurations or the portions of reality, basically. And in this case, I have a problem that if we accept that they are a configuration, then they should be more than the bunch of, let's say, adding individuals with ends, right? There should be like some sort of, I'm thinking more like a system, maybe. And then what we are trying to find is what this system is in the reality. And if we find it, then it is our answer. Is this correct assumption, or do you have any?
Yeah. So I'll take care of this one. So the idea of configurations came into the picture along the following lines. So for a long time in the world of ontology, this is before the year 2000, we were thinking about ontologies in relation to sentences or propositions. And so we were thinking about facts in the world and about states of affairs in the world. And these are combinations of objects and processes, or objects and qualities. So the fact that it's raining outside now is a combination of movements of water and a certain location in Washington, D.C. It's also false that it's raining outside now. So that was the immediate first problem. How do we deal with false sentences? Because there is no. Remember, we were trying to be realists, so everything that we were dealing with as being the counterpart of the sentence or the proposition had to be some real thing in the world. And the solution to that problem, of course, was to distinguish between true sentences for which there is a configuration in the world which makes them true, and false sentences where there is precisely no such configuration, just as there is no such thing as Superman. I said that wrong. Just as there is no such thing which is described by the phrase Superman. Now, when we started to do real applied ontology at the beginning of the millennium, this one, it became clear that if you try and build ontologies around sentences, combinations of nouns and verbs, you will get a horrible combinatorial explosion. Your ontologies will be almost infinite from day one. And so we gradually, this was not a conscious decision, but gradually we moved over to say all the terms in an ontology are nouns, singular nouns, including noun phrases. And then we have, in addition, relations between those nouns, which are always binary because that makes things easy. But in the long run, we will be able to deal with more complicated relations. So now we have just nouns and binary relations. And of course, we can have false statements to the effect that a certain relation holds between the referent of one noun and another. But it's much easier to deal with in this narrow a narrow focus. And what this means, answering your question, is that the talk of configurations, you should really think of it as a talk about truthmakers. In other words, about real portions of reality in virtue of which sentences are true. And so no fictional sentences are true.
Right.
That may be to say that Napoleon invaded Moscow is true, but in the novel, the sentence as it appears in the novel is not true.
And so one way of maybe, at least from my perspective, bringing that back to the conversation, or more specifically to the conversation, is so the configuration. What's there over and above instances, like actual instances that's about. And in the false case, you're not going to get those. You're going to get the intersection of classes or arrangement of classes. Or you're going to get something like a configuration, loosely speaking, that's just not going to have any witnesses, any instances that is in the intersection. So there's the dividing line. Does your intersection have instances or not? You can talk about real stuff all throughout class level, decompose it into classes that have real instances. But that's the dividing line.
Thank you.
Yeah, absolutely. So, Bill. Oh, Bill disappeared. Not to be scared, Bill.
No, I'm sorry. I double. So you said early on in this part of the lecture series that you can have an ICE that is about another ICE. So if I make the claim that Harry Potter shoots lasers from his wand, I make that claim. What I'm saying is that is true about the sentence in the Harry Potter story that says, in fact, that he shoots lasers from his wand. So what I'm saying is true about the story. Does that wiggle us out of this?
I don't know that there's wiggling going on. I mean, that seems right, but you still need some explanation. And I think what you said is it's complemented by the proposal here. I say proposal, but the truth here. But Ryan wants to jump in. Ryan, do you want to?
We had this debate about belief, attitude, intent.
Can you hear
bad guys?
Can you hear Ryan?
Yes.
Okay. Go ahead.
Yeah. So what Dr. Major just said, hey, this assertion that Harry Potter shoots lasers is true because it's in the story. I don't even know that it doesn't even matter if it's true or not yet. What's true is that someone thinks it. And what we were trying to get to is it doesn't matter that the thing doesn't exist physically yet, but it exists when someone thinks about it. You could measure someone's brain waves. We're closer than ever to convert that electrochemical, biochemical signature into what people are literally thinking about. The fact that they think about something means that the thought exists, has either been realized into an action or a real entity, and it doesn't even have to be true or not. That's the separate issue with what other context or data or information do you have to get confidence, like you're talking about earlier, John. That's I'm trying to get to practical because I appreciate we're in a philosophy class and we're talking, but this is the stuff that drives like Denise crazy, and then I try to dial in when we have practical conversations about how do you take what we're learning and use it to solve someone's problems, and trying to dial in and understanding if people possess a belief, an attitude, or intent that we care about. How can we detect it, and what's the degree of confidence we have that that belief, attitude, or intent could be actualized?
I do want to.
That's what I'm thinking about.
Yeah.
Get to practical application.
I want to draw. So what I just want to draw attention. What I'm saying is a practical application. Even though I'm talking about fiction, I'm talking about simulations and blueprints. But the analogy holds for intelligence assessments. You are playing a game of Clue. This is the model. This is a model of Clue. If you're doing geo-tracking and you have a bunch of things like out in the water, and this analyst says it's this thing, and another analyst says it's that thing, and you're aggregating all that information. What's going on? What's going on at a logical level? Same pattern, intersections of classes again and again and again. And what I remember was saying yesterday, I don't want to have to sit here and manually inspect and be like, is that instance the same as that instance? Is that occurrence the same? Are they talking about the same thing? I want to leverage machines to suss out that information and tell me when one thing's identical to another. To do that, you have to back up from the on-the-ground cases and think about the structure, broader logical structure of the cases, the background information, like this, like the cognitive assessments, like the characterization of things are falling in or out of intersections of classes, because that's what the machine's reading, and that's what's going to help you push a button and have your inference engine tell you when A is the same as B. That's where we're headed. So I don't want to foot stomp this, even though it probably sounds a little philosophical. I told you this is about as philosophical as I'm going to get. This is a case that's used in real practice. All right.
With Aaron, where he was like, "We can't model intent." I'm like, "Yes, you can."
The heck we can't.
Yes, you can. If someone thinks a thought, that thought exists.
Yeah. Right. So is it Cem, C-E-M? I'm sorry if I'm mispronouncing it, but I believe you're next on the list.
All right, it's Jem. Yeah.
Jem.
Yeah. So I had a question regarding the difference between conceptualization, conceptualism and realism. I was curious whether phenomenology might play a bridging factor between these two, because even though in ontology we are trying to map the real portions of reality, there is the first person reality is also reality, and whether that might also find its place in ontologies with the perspective of phenomenology. Thank you.
Absolutely. I don't find there to be a bridge needed in this debate. So I know there's been like years of discussion, like on many sides, on like realism versus conceptualism versus pragmatism and all this good stuff. And I know Barry's going to jump in a second, but for me, I don't see these as needing bridging, because when I'm talking about realism, it's just the bigger boat. I am fine with modeling phenomenal experiences. Now, I hit you in the foot with a hammer. You act like it hurts. I don't know if it hurts. I have an evidentiary profile of whether it hurts. I have abductive inference that is drawn out from the evidence I have from what I'm seeing and what I know that it hurts. I make analogies between what I would experience if I hit myself in the foot with a hammer, if you hit me. All that's real. That's modelable. That's real. I will model all of that. I will model the world, the real world, and all that's within scope. Conceptualists focus largely, like their intent is to characterize how we're conceptualizing language and our own understanding, whether or not it lines up with the world. That's to me the difference. And so we just have a bigger boat.
So I'm interested that you talk about phenomenology, Jem. That was where I started doing philosophy, I guess. And I still read a lot of phenomenology, but I read the authors who were realist phenomenologists, who are by far more interesting than the conceptualist or I don't know what the word is, those phenomenologists who think that the way to do phenomenology is to look on the inside. I think the way to do phenomenology is to look at how we relate to things in the world. And in fact, Bill Mandrick, who will be speaking in a few minutes, he also comes from the same background. So the early realist phenomenologists contributed a lot to what we've been doing.
Are there any example authors or books that you can suggest to me for?
You send me an email and I will point you in the right direction.
All right. Thank you very much.
All right, Victor, you're going to close this out, it looks like, unless you have a very quick question. We got 2 more minutes.
Yeah, actually, this is just a kind of scientific question.
Oh, let's talk about Bagwell. I didn't even see you.
Oh, okay, sorry. I didn't raise my hand. I posted a question in chat.
Do I have 30? Oh, wait, hold on. We got a lot longer. You guys keep going. We're on until 10:30. So keep going. All right, Victor Bagwell, then Victor Liu. Or Victor Liu and then Victor Bagwell. Whoever wants to start.
Actually, my question is already in chat. It's what is considered real? Because in science, a lot of the theories are subjective, right? So physics theory, whether it's Newton's law or the theory of relativity, are all kind of up to the explanation of the observation at that time, right? So when we're talking about Superman, if we feed the information to AI, how does AI know is Superman actually real or not? Or it's a work of science fiction, or it's kind of a fringe science, meaning it's somebody trying to do science, but not really depending on existing observation, etc.
So this is a big problem for the entire ontological enterprise. If we want to move ontology in a direction which will mean that it is able to cope with the work being done by modern physicists, we're going to face a horrible problem because there is no single consistent grand theory of physics that everyone agrees with. What we're doing at the moment is we're doing those parts of the ontological effort which we can do with confidence without falling into some kind of horrible self-contradiction later on. So we start with very, very simple, commonsensical facts about the world, such as it's not raining in Washington and we are sitting in a room and John is nodding his head. And then we move into those scientific areas, and there are several of them, where we do have a strong confidence that the scientists are on the road to telling the truth, as is proved by the fact that they all agree. So the entire field of genomics, on its fringes, it's still making new discoveries and settling old controversies. But there's a huge body of common knowledge in genomics and in all the areas of biology and medicine which rest on genomics, which we can, and which we are, or which people in biology are successfully representing using ontologies and using BFO-based ontologies as a matter of interest. Similarly, we can get a lot of ground which the ontology approach can usefully cover in areas like industrial manufacturing and in areas relevant to the DoD or DOW and CBP and so forth. So, but that leaves the question, how do we deal with the really hard questions of science? How do we deal with mathematics? And I'm going to be talking about that at the very end of this session.
And I can pick up here. Let's do this. I think this will be instructive. So let's take a scientific theory and walk through it. So you said Newton, the characterization of like the celestial mechanics, right? All the way back in the day, Principia, right? So what is he doing? He's proposing abductive explanations and mechanisms for trajectory motion. Like, here's what's going on. Here's a calculus that helps you figure it out. All this good stuff. It's actually geometry, but whatever. He loved geometry. This famous anecdote of his, like he notoriously didn't laugh very much. And then somebody asked him one day after he'd written his famous work in physics and optics, they were like, how important is Euclid's geometry to studying physics? And he like uproariously laughed. It was like the only time anybody heard him laugh. it's like everything. Anyway, this is Newton. Yeah. Anyway, this is aside. But So I walk through this theory. What is he doing? He's observing things that are going on. I mean, there's a black plague going on, so he sequestered himself in some farmhouse and was just trying to figure out how the trajectories of motion works. And everybody prior to him, like mathematicians, natural philosophers, have been trying to do the same. He's reading this literature, he's understanding it. He's very clever, so he's thinking very hard about what explains motion from there to there. Why is Ptolemy wrong? Right? and he proposes propositions, assertions, descriptions of how the world is. These are hypotheses. These are things that will be tested and have been tested. And for many, many years, they were tested and confirmed. And as we got more and more precise in our testing, we started noticing differences and issues. When we got to a lower higher fidelity and lower granularity levels, we started seeing deviance from the initial characterization that Newton laid down, and we started branching off into other areas of physics. Like we started hearing about Einstein and talking about boundaries on light speed and whatnot to explain, again, all of the phenomena, all the empirical evidence that we can now see because we're looking at it through different lenses, through these hypotheses that have been born through time, is verified empirically to some extent. Now, all science, all theorizing is necessarily false. Can't get that precise. We can get careful enough to make decisions and create technologies and whatnot. There's still true enough in this sense. And all of this, by the way, all of this, I will say, I'll put this to the table, and this is why I'm belaboring the point, is compatible with what I just told you about about fiction, about simulation, about cognitive architecture, intersections of classes of things. Where are your hypotheses and your axioms? Newton says F equals ma. Intersections of classes. Was he right? Right enough. Some researchers said phlogiston explains heat transforms. There was an intersection of classes that characterized phlogiston. There was no instance of phlogiston. They were wrong. They made assessments saying this is real. And then other evidence that was born on those hypotheses disconfirmed them. And so we realized over time that there were no such things. Murray Gell-Mann won a Nobel Prize screaming into the wilderness about the existence of quarks as explaining so much phenomenon. For many years, people thought this guy's insane. Go back and look at the literature. They were like, this guy's a nut job. 6 things, what? Up, down, top, bottom, strange, and charm. These are crazy. This guy's crazy. Born out by empirical evidence, won a Nobel Prize, right? Intersections of classes all the way down, fundamental logic all the way down, and assessments about whether it's accurate or not, all the way down. So your question you started with was what's real? We're trying to figure that out. In this case, we're talking about real classes, real types of things that have been born out through empirical inquiry. We have consensus around. Barry and I are not experts in various fields, right? We are fundamental ontologists. We're describing things. And so we rely on expertise from others like Newton, rely on expertise from physicists to tell us what the types are, the classes are. And then we just carefully model the background information around it, as well as what they're talking about, and see how the evidence lands. All right, who's next? Other Victor.
If you're speaking, Victor, we can't hear you.
I think he's having trouble with the audio. We did have a question in here if you want to give it a shot.
Yeah.
Yeah, you have a question here?
So maybe not even very relevant, but the practical consideration of like Superman and Krypton, like is it enough to decompose two things that could be further decomposed if your model doesn't care about those unreal things?
Oh, I love this. I love this. So think about what I'm describing when I say a decomposition of classes into real types, right? So I will say, in the accurate model, the characterization of some expression like Superman is strong goes all the way down, recursively spells it out in terms of real entities. And even if your use case doesn't need it, I would do that anyway. It's a recipe. And then you just cut from that bigger picture what you need and say your application.
Resources are always limited.
For sure, which is why it's a recipe. I like recipes because you can code them. Write some scripts. feed it to AI, have it generate according to the recipe, and this is your law. So it's easier now. I don't like writing definitions. Like, I don't mean genus species definitions. I mean like Python. But generative AI will do that for me, like the monotonous stuff. I like to create design patterns and recipes that are monotonous, even if they seem complicated. This is the sort. So I write scripts that generate the broader structures. So I don't have, because resources are limited. And then I cut what I need. But so I wanted to highlight one other thing, one other feature about this, because even though like fundamentally the distinction drawing here is the intersections of classes with or without instances, unreal things versus real things, real at one level, real at both. But you think about a characterization of something like Superman or Harry Potter, and ask yourself this: what's Harry Potter's great-great-great-grandmother's eye color? I don't know. Fiction is underdescribed by its nature. Simulations are often underdescribed. These unreal things are often underdescribed, underrepresented, right? And so it's different from us. Like, what's my great-great-grandmother's eye color? I don't know, but there's a fact of the matter. There's no fact of the matter to what Harry Potter's great-great-great-great-grandmother's eye color was.
Until J.K. Rowling tells us.
Till J.K. Rowling gets on Twitter and says something offensive.
So you're saying that's how we like differentiate if we don't know whether or not something is real, we ask what the fact of the matter is. So
Oh, I like one feature I would say of like that distinguishes say fiction from real world. And it's just kind of it's a feature that is born, it's symptomatic of the difference of between instances or non-instances. The symptom is like fiction is necessarily underdescribed. The world is not, because it's right there. Yes.
So yesterday I mentioned Roman Ingarden, who is from an ontological point of view the most important of all the phenomenologists, because he contributed so many proposals to the way we should deal with ontology properly in difficult cases like fiction, for instance. So his most famous work is called The Theory of Literature, and it gives an account of the structure of the literary work, which I'm going to be talking about at the end of this week, in order to illustrate some of the points that we're talking about here, but also to move into areas like politics, the theory of the state, because I think what Ingarden had to say about literature can be applied also to areas like the understanding of the state. Now, what does Ingarden say? He says that the structure of the literary work includes several strata. There's the strata of words, word sounds. There's the stratum of events. There's the stratum of represented objects and object collections, for instance, representing Anna Karenina. And then he says the feature of all entities represented in literary works. Ingarden differed in his ontology here from John's and mine. He thought that there are fictional characters, but they're in our minds, basically. The difference between all represented characters and all real entities is that all real entities are determinate in their makeup down to the lowest possible difference. They have an exact height, they have an exact weight, all of their body parts have an exact placement relative to all the others. The color of the hair is always what it is. Of course, it changes over time. But that it does that exactly. So the real world is characterized by exact determination. The world of fiction is characterized by the fact that every single represented entity has what he calls loci of indeterminacy. That means that hair color is not defined, their age is not defined, their address is not defined, their relatives are not defined. There's no way of finding out infinitely many things about Anna Karenina. We can find out a few things because Tolstoy told us. But most of what would hold of Anna Karenina was just partial things. Most of them would be typical of young girls in Moscow at that time. And we import those when we read the novel. That's another feature that we need to remember.
Yeah. Absolutely.
All right. Now, why did I want to say all of that? Yes. So Ingarden was not primarily interested in literature, although his most famous book is called The Literary Work of Art. The subtitle is An Essay on the Borderlines of Ontology, Linguistics, and the Theory of Literature. So ontology came first. Why is that? He wanted to understand whether realism is true. Realism says the world exists, and it's more or less like we say it is. It's got people in it, and not non-reflective whiteboards, and so on. So that, and they're all real. They all have completely determinate characteristics along every dimension. But the fictional world is all such that it's indeterminate. It's not determined down to the lowest differences. And Ingarden said, well, which is, if we want to understand what the real world is like, I told us I'm getting the punchline wrong, so let me move back. The real world, which we think of, is completely determinate. The fictional world is always only partially determinate. What is the real world like? What is the ontology of the real world that we should accept? Is it an idealist philosophy, which says that the world is a creation of our concepts, which we share to a large degree? Or is it the realist version of philosophy, which says that the world is this determinate thing which is outside, which we do not make, we discover? So Ingarden used his analysis of literature as a tool to apprehend the features of what the world would be like if it was created by us or by Tolstoy. It would be full of holes. The real world is not full of holes. We can check the weight of everything at every minute. We always get a value. We never come back with no value. Now, that is fine in 1935 or thereabouts when Ingarden was writing this. Now we have quantum physics and things. And so the questions are now to be seen in a different light, but I'll be talking about that too on the last day.
And this is a perfect segue. So we are going to pause for our 15-minute break. Thanks, everybody. If you have more questions, feel free to drop them in the discussion board or in the chat here. We'll try to get to them. After this, we will kick off in our next discussion, which will be focused on the law. So we'll keep the recording up here, but we'll mute so you don't have to listen to us, Jabber. Be back in 15.
All right. So
go ahead.
This next session features a former student of mine, Bill Mandrick, whose PhD dissertation was titled The Ontology of War. He was at the time in the army, I think in Afghanistan, when you wrote the thesis.
Yes.
And then he became a colonel, and then he went back to ontology, and he's working now on ontology related to CBP. Is that right, Bill?
Correct. Yep.
And today he's going to address some of the issues which we talked about earlier pertaining to phenomenology and how social structures are to be conceived from a broadly phenomenological direction, but without departing from realism. So fire away, Bill.
Okay. Can you see my bamboo forest?
Yep.
Okay.
Yep.
So that's where my slides are going to come up. So yeah. So just a little bit more about myself. So after I got out of the service, I finished up here in Tampa at Special Operations Command, and went to work for Defense Intelligence Agency, and then I went into aerospace, and now I'm back over at Kubrick, and have been working on the ontology of law. So let me bring up my slide deck here, and you should be able to see that now. Can everyone see that? What kind of thing is law? Can you see that?
Yeah, we see it.
Now, right out of the gate, I probably made a little bit of a mistake in writing my title. In the ontology, we don't like to use mass terms like law, right? What kind of thing is a law? But I left it as it was. And you can see the subtitle there, From Aristotle to Artificial Intelligence. I'm going to go through that kind of fast, but I want to give a little bit of the flow from Aristotle and how this has gone forward in time to where we are today, and hopefully that'll help. And the second part of my lecture, debate, whatever we're doing here, I'm going to talk about actual units of analysis, classes of things in the law that we can reason with. Okay, so by the end of this, you should be able to understand this process that I just talked about, going from Aristotle to where we are today. And a little bit of more, you should have a better understanding about ontology engineering, how we elicit questions from subject matter experts, and from those questions, we create ontologies and knowledge graphs, right? Okay, so really, this should say you should better explain ontology, what it is and why it matters to law, right? Understand how philosophy shaped modern legal ontology. And I'll just go kind of quick here. Appreciate legal systems depend upon objective structures. That's really kind of the main part of these next few slides. Distinguish between physical, social, and legal entities, right? And recognize why formal ontologies are essential for AI, knowledge graphs, and what they call computational law. Okay. Okay, so here's what I was talking about, this evolution of thought. So I'm gonna talk about each of these people that you see here and how they're kind of connected. I'm not going to make the claim that in some cases it sounds like maybe one thinker, philosopher was reading another. I'm not making that strong of a claim, but I am saying there is a connection between these people, right? And you can kind of just survey this slide, and with each of the people, there's a question there. And that's kind of what I want you to think about as we go forward and I present each of these philosophers, ontologists, economists in De Soto's case, and how these things all connect. Okay. So let's start out with Aristotle, then we'll go talk a little bit about Husserl and phenomenology. And then he was Reinach's teacher, and Reinach was a lawyer and an ontologist, phenomenologist. And then how, going forward a little bit more, Austin gave a series of lectures on doing things with words. And then that had some impact on Searle. I don't know if they knew it. I don't think they knew each other, but there is definitely some similar activities going on there. And then present day, we've got De Soto and obviously us, Barry, and all of us that are working on the present formal ontologies, right? So Aristotle, way back in the day, is looking out in the world and he starts to think about categories, like things like there's these material objects and they have potential to change in a process. So we can talk about potentiality and change in time and space, right? So these first observations are what started in where we are today. We can still kind of, we use those, right? So these are good references to go back and read, right? And so the science of being, that's what this is all founded upon. Okay. Now, so here's some Aristotelian categories, right? Because we care about categorizing things in ontology. And then there's my legal example over there. And we're gonna go a little deeper into this. So for substance, we have people, mountains, buildings, courthouses. That would be a building that's in a role, right? And then we have relations like ownership, qualities and dispositions, processes or actions, the signing of a contract. We have places, jurisdictions, sites, different sites. And these things unfold in time, right? So there's space and time at the bottom there. So again, the point here is not is that Aristotle's, these thousands of years ago, is looking out in the world and saying, in reality, hey, we can divvy up the world into these different categories, and then we could better talk about them or clearly represent them in our speech and in our thinking. Okay. The other thing Aristotle gave us was this if we're going to define something, we're going to use this two-part definition based upon categories, right? So all definitions we're going to write as ontologists, we want to use the two-part genus-species definition. That is to say, the first part of the definition will refer to a parent class or the genus, the general thing. And then you're going to add the differentia, which distinguishes it from all the other things that fall under that genus. So in our example, we can do it with animals, we can do it with terrain features, but in our example, we're going to do something like property deed, right? So that is a genus, it's a prescriptive information content entity. And it's different from other prescriptive information content entities because it documents the conveyance or ownership of a parcel of land, right? So that's how we're going to write our definitions as ontologists, and we get that from Aristotle. Jumping forward, we're going to talk about Husserl. So Husserl comes along, and he is the founder of phenomenology, right? It's a method for investigating essential structures. And he focuses on our intentionality, the way we think about these structures. So now legal concepts can come into focus here a little bit more. And he's going to talk about things like this notion of states of affairs, right? So reality consists not only of material objects and events, but these states of affairs, Sachverhalt. And examples would be Alice owns Blackacre. Bob owes Alice $500. This is a valid contract. The court entered a judgment. These are structured situations that legal systems recognize, and we need to be able to reason over them. So that's where we're going to go for the rest of these slides. So now you think about Aristotle, and he's divvying up the world into categories. And then Husserl comes along, and he's talking about the phenomenology of the way we think about the world. And we've already talked a little bit about this, but this is important. I'm going to re-stress the three orders of reality. So first order reality, those are those real entities that we were just talking about. Material objects like mountains and buildings and vehicles and people, right? And then those things have parts. We could talk about object aggregates like a group of people, an organization, a cluster of buildings, right? And then the relationships between those things are, in a certain sense, real. And then the realizable entities, these are things like functions, roles, dispositions. Maybe in Aristotelian terms, these would be potentialities, right? And then we're going to talk about space and time there at the bottom. We can think about things happening at different sites. So in real estate, we talk about the value, maybe we talk about the value of a building, but the physical structure is only part of the story, right? It's the sites, the rooms inside the building. So maybe it's a combination of retail sites. They have stores in the bottom and residential sites above. And that's what creates, in a certain sense, the value. So it's not just the physical building, it's the immaterial sites within the building. And this applies in time, right? So we can add time to that. But then there's the way we think about these things, the mental world, right? So we've got our intentionality, as Husserl talked about in phenomenology, the way we think about things and perceive things, and then our reasoning processes and our interpretation of first order reality. So there's second order reality. And then the third order reality is, again, how we represent these things, the things we say first order logic, math, databases, knowledge. Ontologies are third order representations of the other two orders, right? So we can have an ontology of second order reality, but it's just that. It's an ontology of intentionality, cognition, mental functioning. And it's important that as we go forward, we distinguish between these three things. We're careful not to conflate them. Okay. Then comes along Reinach, who is Husserl's student. And it turns out from what I've read that Reinach was a much better teacher. And he, being a lawyer, he had this notion that that law has an a priori structure. And I'll explain what I mean by that on the next couple slides. So this a priori structure is there. We don't make it up. It's not in the positive law. It kind of supports the positive law. So an example would be, let's take a real world example. John and Sue. John, they're out at a party. John forgets his wallet. John and Sue are friends. He says, Sue, loan me $100 and I will repay you when I get my wallet. And Sue says, no problem. Promise accepted. Right? So now they've performed this act of promising where John takes on this obligation role and Sue is a claimant, right? The obligation and the claim are mutually dependent on each other. You don't have one without the other. Okay? So now a claim and an obligation have come into existence based upon that act of promising. So that John takes on a promiser role and Sue takes on a promisee role. And those are also, those roles that they have are also mutually dependent, right? Now, you're thinking something's missing here. Yeah. So at the bottom there, you see we have this state, and I don't know if this is right. I think this is right. We have a stasis of roles, right? So what I mean by that is John's role as the promiser and Sue's role as the promisee, they exist. Let's say they forget about the money, right? And they forgot about it for a year. That stasis is still there, I would claim, right? He's still in that promiser role, and Sue still has that promisee role. The claim and the obligation still exists, even though they're not thinking about it. And I think this was one of Reinach's main points, is that structure is still there. And let's say a year later, they're at that same venue, and John's just like, oh my gosh, Sue, I forgot to repay you. And he pulls out $100 with interest. He gives her $120 back. And he says, I am so sorry I forgot about that. And Sue says, I forgot too. Now we're back at metaphysical state zero, right? The obligation and the claim go away. And that's what I mean by that stasis of role. And now that happened in space and time too, right? So we can bring that in, and we'll do that later on in this slide deck here. Okay. Now, a little bit later, we get Professor Austin comes along, and he starts this lecture series on how to do things with words. So we talked earlier about, we said Harry Potter has the ability to shoot lasers from his wand. And that's a certain type of statement. And we were saying how that's a statement that's about some unreal thing. Or we could say a real thing. We could say something like Francois the cat is sitting on the mat. And we're just reporting something about the world. We can say it's 72 degrees outside. Austin comes along and says, well, wait, what about when we say something, it does something. And we were just talking about this promise that just happened. And that's where I think Austin's going with this. When we say things they have a creative effect. And That was from his lecture series. So Austin is going to talk about things like marriages. I pronounce you man and wife, right? Orders, commands, and things like that. So these are creative statements. And so he's calling them performatives there in that quote. They're not true or false. They're creating something in the world. So if the I promise to repay you, or you are hereby knighted, those aren't true or false. They're creative statements. Okay. My slide deck stopped working there. Let me go out. Okay, there we go. Now Searle comes along and he says, well, what about collective intentionality, right? When we're not just doing individual promisings, but we have this in a social setting where we're going to put society right on top of this, and we're going to create institutional facts. And he goes on to talk about this very powerful statement here: X counts as Y in context C. So, for example, the piece of paper in my pocket counts as a dollar bill in the context that we all recognize that. Now, what's left out of here is the institutions that support that. But again, we're talking about the creative powers of these types of statements and these intentional things. Now, De Soto comes along, and so Barry's worked with Hernando De Soto, and he wants to talk about how this happens in economics, right? So assets aren't automatically capital, right? A house is just a physical object. A parcel of land is just a site. Neither automatically function as capital. That requires a legal infrastructure. So if you go back to what we were saying earlier with Reinach, that promise graph, that applies to this too. So we have people that are interacting, and what De Soto is saying is we need a system to represent this. And we talked about information content entities earlier. Those are the placeholder. I guess you could call them placeholders: titles, deeds, surveys, cadastre maps, land registries. And that's what brings the possibility of economic activity and value, right? So property rights create trust. So in a society where you don't have the information content, literally you don't have the ICEs required to set up property, required to say that's your piece of property and that becomes more valuable because of that. In those societies, we have instability. This has been proven. And that was one of the some of the research I did when I was at Special Operations Command, was going in and getting economic intelligence. Do people have property rights? Do they, when someone is squatting on a piece of land, do they own it? Because what happens if they don't own it? A bully can come in and just say, it's not yours, I'm taking this, right? So that's what he covers in The Mystery of Capital and The Other Path. Okay. So we want cadastre maps, we want property deeds, we want all those things that stabilize a country, and we can actually tell a lot of things about the stability of the country based upon those documents. And here we are today, where we want to take those theories, those thoughts, and we want to put those in a rigorous format so that both humans and computers can understand them and reason with them. And you've probably seen this book, right? So that's a a book on realism. And here's the down and dirty right here is we get to basic formal ontology. And this is a theory of reality, of realism, where we have material objects there in the bottom left, right? So for our purposes, we're going to talk about today, let's talk about properties. So we might have an object like a building or an object aggregate like a mall, shopping mall, or a campus of buildings. They sit on some site, and in the site might itself be valuable, right? So the placement of those buildings might be valuable. And we have certain qualities, roles, functions, and dispositions of those buildings. We would also have people involved over there under material entities and the way they interact and their function, roles, and dispositions. And those are realized in a process, right? So we have legal processes, we have real estate processes, that process of entering into a promise, right? And that happens in time. Now, what we're really going to talk about here in the second part of my lecture is all of that, but really focused on GDCs, generically dependent continuums. And we've got GDCs that describe the world, they designate things in the world, they represent things in the world, but what we're going to talk about mostly are the ones that prescribe or prohibit or require action. Okay? So, Aristotle taught us to ask what kinds of things exist in the world. Searle showed us ways of investigating that, thinking about that, these essential structures, eidetic reduction, and phenomenological analysis. Reinach came along and applied that to the law, objective legal relations, if you want to call them that. Austin explained how speaking can itself be a form of action. It can create new things like you are now a knight, you are married, etc. Searle examined how collective recognition results in social reality, institutional reality, and keeps it going. And then DeSoto showed that those realities underpin economic development. And here we are today, right? So now we're at a point where we're talking about these legal entities, these social structures, and we want to represent them in such a way that humans can reason with them and computers can also process the things we want to represent. So I'm going to stop real quick. Sorry that was fast, but I know we're covering a lot of these things. And I want to open it up for comments or questions before I get into the main part of my lecture. And again, the background was just, if you're interested in going back and reading those things, that can't hurt to go back and read any of those authors. So I'll open it up. Oh, Olivia Hobai. Why don't you ask the question? Hi.
Long time no talk.
Yeah.
Could you please go back to the slide with the 3 layers of reality, or 3 levels rather?
Yes. Let me where'd we go with that? Oh, wait, I lost it there. Hold on, I lost it, Olivia.
Well, we're not in a hurry. I'm not in a hurry.
Okay, there we go. Hold on, it's coming. There we go. Okay, go ahead.
Thank you. So when I was working on the ontology of law with you, a major sticking point for me was that too much depends on the second order of reality, that is to say, legal interpretation. And especially when you were talking about legal entities that prescribe, require, or prohibit other entities, my issue is there's a great deal of inconsistency and variation depending on who is interpreting what law under what administration, or depending on the legal role that one has. And I was wondering if you found a way to represent this or address this in your work.
So, Olivia, do you have a use case for that?
Well, yes, in a trial, right? The attorney and the prosecutor and the judge all must interpret perhaps even the very same law. Let's say it's a criminal law. But then their interpretation will differ because maybe there's evidence that one of them's considering that the other is not considering, or the language of the statute will be taken more strictly or more loosely depending on the case. And I think this is an issue for understanding exactly like the category, like what legal categories boil down to in the world.
Okay, you're not gonna like my answer.
That's okay. I just wanted to ask the question.
Well, yeah. So I'm not being a lawyer. David Kopsel is. I'm going to kick this over to him. David, do you have any thoughts on that, or do you want to wait till you present to address that?
I do have thoughts, and the thought was wait until I present.
There you go. So Olivia, we're gonna kick your question. We're gonna kick it down the road a little bit.
All right.
Okay.
Thank you.
Yep. And David, you have your hand up. Please go ahead.
Yeah, actually, that was just so that I could interject that thought. Now I've got to figure out what it does.
So we'll come back to Olivia's question. Great. Lauren, your hand's up. Go ahead.
So maybe this shouldn't be done, but I think this is really interesting. So I just give 2 cents on Olivia's question. One is that the law is meant to have that. So like, because we are in this situation all the time, we have to interpret the legal kind of constraints and permissions and obligations. And one thing that I've learned from reading a bunch of legal stuff is that they build in this uncertainty, is how I would see it. So it's there by design, which is for me frustrating, but I think we have to accept how things are. And then the other thing is we have a colleague, Corina Coupe, who's a computer scientist and a lawyer, and she is working on this concept called legal hypergraphs. So the idea is to think about, what do you do when things, so this doesn't exactly answer your question, but like, what do you do when, the constraints and the policies and the obligations are looking different in different kind of situations? It speaks a bit to what you said. So I'd say that this is kind of an emerging concept that I think would be interesting and useful here.
So good point. And we're going to dive into that. Danilo? I'm probably butchering that. Sorry.
Okay, no problem. Yeah. I'm Danilo. I'm a lawyer by training, and I'm trying to catch up the debate. And adding up to what the women said, it's like there are some concepts or ideas that are intrinsic to legal debates. For example, if there is a lack of a rule, and you can find this concept in Norberto Bobbio. It's an Italian philosopher or legal philosopher. And there is cases of antinomy when you have rules saying different things and you need to decide which rule will prevail. So there are different aspects or entities or things in the legal world that it's not just it's a risk to say that, but it doesn't seem to represent just the realism. It's more like, for example, an absence of an entity and things like that. But many of those things are in a way, in a narrative, is an interpretation of someone. So someone would say, "Oh, it must be a rule about this thing," and another person would say, "No, there is no need for this rule. The rule or the norm is to not have any norm regarding this." So those are things that, if you could, I would like to understand
So
your view about.
Bill, I'm going to step in here
Yeah.
and just point out one thing to Danilo. The absence of an entity is also a part of reality in a certain sense. Absence, it has to be registered perhaps in order to count as an absence, but still the absence was present already before it was interpreted as such. But now I think we should move on to David. Are you ready with your slides? Are they on the screen now?
Well, Barry, I'm going to go through this real fast and then hand it off to David.
Okay, so you have 5 minutes, Bill.
Oh, okay. Let me go real fast. So
Yeah.
Olivia will be very familiar with this. Olivia and I co-authored a paper on the units of analysis. So what would an ontology of law consist of, right? So we've got, here's the points. I'll go real fast here. That second bullet there, structure versus content. And right now there's 3 comparable ontologies. We got the IEO, the IAO, and the DOCO. We compared these to come up with the proper classes that could serve as a reference ontology of law. And why this matters for AI, because we want the ontology to be consistent so that it can be better used by AI, right? So structure versus content, that's the takeaway here. A legal document has a certain structure. It has IBEs, information bearing entities. It has ICEs, information content entities, right down to individual, you see on the right there, clauses and subclauses. Those are individual statements within the document, right? So here's the 3 ontologies, IEO, IAO, and the document components ontology, DOCO. They are all different. They all talk about the structure of a document. In some cases, I think in the DOCO, they conflate content with structure. And I think we need to fix that. But this is really a call to, we need to fix this. As an ontological community, we got to come up with something that smooths out the differences between these 3 approaches, right? So the DOCO, for example, has these parts of a document. And unfortunately, in the DOCO, the component ontology, they do a little bit of conflating where they combine the structure of the document with the content. Okay? Here's the 3, this is my claim, that in the CCO and the information entity ontology, they have document and document fields. In IAO, they have document and document parts. And then in the DOCO, they have a structured element and a container element. And then they have, you can see they have back matter, quotation block. So what I'm saying is these all have compelling approaches, but I think we're of the opinion that we need to figure out what maybe combine the 3. I don't know. Right. And so now we go from content from structure to content. So within the information entity ontology, we have directive information content entities, like laws and regulations, right? Those things are about the world, right? So the property deed is about those things. You can see the graphic for yourself, right? So the property deed, and at the bottom there, you can see where the property deed is about other things, other pieces of information. Like the property deed is about a survey, it's about a mortgage, it's about the rights and obligations, the ownership, right? So you can see this, go over this on your own. Information content entities to continue. Examples would be deeds, statutes, court opinions, passports, arrest warrants, right? And legal documents are information artifacts. Let's see. All right, so this is from the Code of Federal Regulations. You can see they're already they already have built in the structural elements. And you can click on things and it will take you to the other references. Let's see, I'm trying to go fast here, sorry. this was the structural things that we had in there: document part, document chapter, clause, section. These are the content, the law, the criminal law, the state law. And then we have to add in our object properties. This is that aboutness that we talked about earlier, where a law or a regulation prescribes, it permits, it prohibits, or it requires something. So we use that to create our triples. And here's some examples real fast here. There's the object properties we looked at and their inverse. So on the left, you see the object property that creates the triple. And then on the right is its inverse. We talk about parthood of the document, and then we talk about prescribing, permitting, prohibiting, requiring, right? So the activity is permitted by the law, it's prohibited by the law, or it's required by the law. Hierarchy of how these things are connected. You've got the Constitution connects to the United States Code, which then connects to the Code of Federal Regulations. This was what I was going to talk about with tradecraft. Let's say we have this decision support question. What laws or regulations serve as the legal basis for the patent application process? That turns into more specific competency questions. What do you mean by process regulation? What is the U.S. Patent Office? What is a law? What is a patent? What is a patent application? What is the process, et cetera, et cetera? That creates potential classes that probably already exist. And then you find the relevant data that applies to those things. This is how we're going from a very general question moving towards the knowledge graph. So there you would have, that would be a resulting potential knowledge graph for the patent process. Okay. So you can get right down to the parts of 37 CFR has those prescriptions for, you got to have your name, you got to take an oath, you got to have a detailed description, drawings, et cetera, et cetera, et cetera. So the Constitution is the legal basis for U.S. Code. So there's the clause within the Constitution that talks about patents and intellectual property. That's the legal basis for the U.S. Code for the powers and duties of the United States Patent and Trademark Office. And that serves as the legal basis for the patent process, right?
Okay, so that would be a good place to stop, Bill.
Okay.
So we get the idea, and I hope we have time to go back to it in the discussion at the end. But we need to introduce David. So David is another former student of mine who's published multiple books on interesting topics such as Breaking Bad and philosophy, and now he's going to talk about the law.
Thanks, Barry. So I want to share my screen. Am I authorized to do that yet?
Should be.
It says I cannot while another participant is sharing.
Oh yeah,
it.
Bill, you need to unshare if you are still sharing.
Okay, now I can. All right. So thank you, Barry. Thanks, Bill, for that introduction to the field. Some of what I'm going to say is a little bit along the same lines, but I'm going to get thicker into the weeds, I think, about my own work on legal objects. So when I was defending my dissertation with Barry in I'm not going to say the year, but 29 years ago, I was a practicing lawyer, and I've been a practicing lawyer on and off for a while. So some of this is actually derivative of my work in the law, as well as my work writing about the law and legal ontology. And in October, my book, A Structural Ontology of the Law, will be published by Palgrave Macmillan. Currently, I'm at Texas A&M University, where I teach on philosophy of law, and I manage the SEAL program, which is Society, Ethics, and Law, which is a degree program for pre-law students. All right, let's see. I just got to coordinate my slides here. There we go. So can you see my first slide here? Law has been modeled.
Yep. Yeah, but you need to give us the presenter view.
Okay. How do I do that?
You go to the little icon which seems to show a podium at the bottom of your screen.
Okay.
It doesn't matter if you can't do it. We can see.
You're seeing my presenter, my notes?
Yeah, I think you fixed it now, David.
So I need to.
Oh, you're good now, David.
Okay. So now it's good?
Yeah.
Okay. So I want to talk about something first, and that is the sort of thing that lawyers look at and the way that we understand them, and as lawyers practicing law, and the way that the public understands them isn't necessarily the same, but in the law, everybody understands how an order works. And there's a lot of interesting philosophical stuff about it. For instance, a legal order that might, look like this functions despite the paper. It's not the paper that does what it does, and it's not the particular language it's written in. Neither is it dependent upon the judge's mental state. You can translate this to any number of languages. You could destroy the paper order. You could even go back through the docket and eliminate the file, and the order stands. So, right, what is this order? And a lot of what Bill has introduced us to from Reinach and Searle and others has set this up for us to understand it, and we understand it, right? It's not just an information artifact, but it's something else. It's doing something important in the world, and this indicates to me what the legal order and what legal reality is as a subpart of social reality, is something that stabilizes obligations. So Reinach's unfinished business, so he died prematurely when he was killed in World War I think is in explaining the general nature of obligation and the manner in which the law can sit in contradiction to obligation. So he mentions this in a priori foundations of the civil law, but it isn't finished. And I've been working on trying to understand it. So what is this sort of thing? An order like this? It's none of these four possibilities. It is something else. Now, law's been modeled. There are existing ontologies, and they're good at what they're set out to do, but they're not really describing the legal order fully. So I start obviously from a basic formal ontology perspective, given my connection with Barry's research, and I wanted to ground an ontology of law more completely in basic formal ontology, and describe the nature of such things as a judge's order, and how it continues to exist, and how we can understand legal orders in general, and by that I mean legal systems, based upon certain necessary and sufficient conditions for legal reality. And I don't think we have that yet with the current attempt. So we've seen good realist ontologies in the scientific domains, and I think we're not quite there yet in legal ontologies. For instance, LKIF core gives us a concept list and document structures. FRBR gives us a document-centric markup, but the law is not simply documents. So how do we better understand what the law is? And my conclusion is that the law is an architecture of social being. It's a subset of social reality that I think gives stability to obligations in general. So that's where I think Reinach was heading when he described the a priori foundations of the civil law. Obligations arise pre-legally, and the law is there to stabilize them. And legal systems do this to better or lesser degrees. So let's look at how this works. There are certain necessary and sufficient conditions for these legal systems, and one is recognition. So systems of recognition acknowledge that certain entities or status or claims hold. Our system of recognition, for instance, in the United States, predates our constitutional order. And this is evidenced by the fact that in our precedent, we still reference precedents from England in the tort law, for instance. And that system of recognition is carried on and maintained by courts in our constitutional order that still reference precedents that could, that predate our constitutional order. And then there is, right, so as part of a legal system, not only is there recognition, but there are obligations. And this is I described the structural pull that the recognition installs. So specifically dependent continuance that bind actors and roles to acts, omissions, or status. This is how laws work and legal systems work. And all of this is also contingent upon some system of repair. So why have all these systems of recognition? Well, legal orders set themselves out to repair violations, right? And violations, we'll talk a bit more about that, what those sorts of things are. So in the structural ontology of law, I'm trying to complete Reinach's program from a BFO perspective. Recognizing that Reinach sets the groundwork for this, and right through Searle and Barry, we get a better realist grounding of an upper ontology, where we can describe the sorts of things that exist in the law according to BFO and give some greater interoperability and interpretability to these sort of things across domains. So here, for instance, at the bottom, there are, right, so these various BFO categories of the structure ontology of law, including specifically dependent continuance. Examples are norms, obligations, claims, statuses, immunities, and powers. There are roles. So a judge issues an order not as, right, Doug Smith, but rather as Judge Doug Smith, and it's only in that role that that order makes sense. Other roles are plaintiffs, owners, citizens, trustees, etc. Types of processes we find are hearings, adjudications, enactments, and repair. Types of material entities include those things that bear legal qualities, and such as persons, properties, and documents. Okay, so most legal entities behave exactly like specifically dependent continuance. Now, these are legal entities in legal systems that, right, like a particular obligation. So the particular obligation, Sue, what were their names, Sue and I forget, anyway, from Bill's talk where there's some obligation that might evolve into a contract. An obligation exists only in as much as some person is in some role in a legal domain. So for instance, we might have a pre-legal obligation to fulfill a promise, but in the law, there's only certain conditions in which obligations evolve into actual legal contracts. So then we have what the law would recognize as legal contractors, debtors, and performers, etc. Contracts exist identically over time. So a particular contract exists as it is until such time as it's amended or performed or found void for some legal reason. they can migrate generally to another bearer. So a tort claim doesn't survive transfer to a stranger, for instance. These legal entities come into being through enactments or performances, and they cease to exist by repeals, fulfillments, or repairs. The legal object is not identical to any representation of it. So, for instance, the filing of a cadastral title paper or paper chain, right? The system that maintains the records of property in a cadastral legal system or in and another legal type of system is not what makes the property, right? It's as Bill mentioned, it's the actual site that is the property. But the nature of that object as a legal object exists separately from the object itself. All right, and that's what makes it a piece of property per se in a legal domain. Now, I've decided or determined that there is you have to have actually all 8 of these certain nodes for there to be a legal system and legal objects. Now they're described here. So we have some authority. There are 4 general clusters. There's authority, effect, recognition, and repair. Each of those clusters has some members, including in the authority structure, some authority, some norm, and some role. In the effect structure, we have facts and acts. In the recognition structure, we have some target and effect, and in the repair, some remedy. So each node in a legal structure, and this is meant to be a general description of legal reality. So any legal system includes all elements of the minimal legal chain. Each node depends on its upstream node. For instance, authority grounds a norm. A way to think of this is the right to free speech in the First Amendment is grounded in the authority of the Constitution. The norm grounds some role. So, for instance, in the First Amendment, right, it's the government that cannot infringe upon the rights of citizens to speak. That can act on it, and there's some triggering effects which activate a legal act by that person in a role, and the act lands on some target, producing a legal effect. And when something fails to close, if there's a violation, for instance, then there must be a remedy, or you don't have a legal system. So authority is, in general, who is licensed to speak law into being. So our constitutional system says that, in general, the Congress is that authority. And the Supreme Court is the body that interprets that authority. There is some, there's some system, there's some effects. So what world events convert things into legal acts, or triggering facts are the brute to institutional bridge. So, what makes a infringement of speech a violation of a First Amendment right? Well, in case it's some government saying to some citizen that something can or cannot be said, then you translate that into some sort of triggering fact for this legal chain, right? Then now you're starting to see a legal effect. Most of our, so if I cover Barry's mouth while he's speaking, I don't trigger a First Amendment event, right? It doesn't become a First Amendment issue. It's actually just a simple tort. It's another sort of legal object. Does the effect land where it's supposed to? So this is the recognition part of the chain. And then what do we do in case of some violation? So let's take a look at an eminent domain taking. So
you have 3 minutes, David.
Oh, geez. Okay. So, well, I'll skip over and then we can get to the discussion. So I'll quickly go through this. And so in every legal event or every legal phenomenon, we have this chain, and we can analyze it in that way. Now, why do we do this? well, I think we can actually do some. Now I've lost the ability to. For some reason, there we go. We can find some interesting things about the nature of law. And the other unfinished part of Reinach's business was describing what counts as contradiction. So he talked about contradiction, but didn't really ground it in what I think is a clear view of how legal errors happen. And I'm just going to point you to my work on it, which is all online. And hopefully, we can address some of it in our talk too. The problem is my mouse battery is dying, so I'm going to have to charge it. So,
all right, so I'm going to start the discussion then. So you talked a lot about the law,
right?
As if there is only one law. And Reinach, of course, thought that in a sense there has to be only one law. I'm thinking of law with a capital L now, because the law is somehow a priori, which means that if we do a certain amount of thinking, all of us will recognize that it exists and is the way Reinach and you are saying that it exists.
Right.
Now, I find this attractive. I'm a fan of Reinach too, but there is an obvious objection, which is that there seem to be cultures which have very different approaches to what the law with a capital L should be like. So what's your response to that problem?
That's fine. So as long as those cultures are grounded in the 8 elements of the minimal legal chain, and I believe they are, and I'm doing work, empirical work to try to describe that. I've done it now with the corpus of American law. I'm working on others. That's fine. They may have different views about the source, for instance, of authority, but as long as they have systems, and I think that in order for them to have legal systems, they must, that recognize a particular authority, then the grounding of their legal system is proper. And I think also that if they don't have that, and there is also evidence for this that I'm working on, and you've seen some of it, then the stability of their system is at stake. So if you go to look at what I've tried to show you in my slides, there are systems in which this contradiction, the legal contradiction that Reinach waves hands at but doesn't specify, can be typified, categorized, and measured. And we see that. I had a recent article in the journal Stability that does that for numerous polities. And we can see that, and what I call contradiction debt accumulates and suggests their legal order is in trouble. So I think these things are real. I mean, and they're measurable and quantifiable. And Reinach hadn't finished that work, and I think this is what I'm aimed at.
Okay, so let's turn to Alican and Sarah now.
Thank you, David, for the presentation. I was, I guess, like 1 year ago, I was also interested in the Reinach's, when I was reading it, and it came to my mind that 2 hours ago, I mentioned that a sentence can be the configuration. And I was actually interested that when you showed this order, the document, I would argue that this document is also about some sort of configuration, and not just a one thing, so to say, so that there would be like some sort of structure that you can show that what this document is represented in the reality. But my question is that how then did you analyze, if you have done such things, like how do you say that this document is look like this structurally, for example, as the in some, for example, language, like it can be like a first order logic or anything, and then you start analyzing it basically, like how you are representing these documents, so to say, in your ontological framework. Thank you.
Yes. So we can so lawyers look at documents in specific ways too. One of the ways we do it is we always look at what is the issue in a particular legal case, what is the rule, and how does the court apply the existing legal rules to this particular case. This pattern is repeated throughout adjudication and all sorts of legal systems, and we can do that with any particular legal document. That's the general approach I've taken. Now I'm using in my work LLMs to help extract the elements of legal cases. So if you go to the my Sewell query tool site, which is right, if you go to my website, you'll find links to it. We can find all of the elements of the minimal legal chain in each of the cases that we're looking at. And so that there's about 6,000 cases I've gone through, and I'm finding the way in which the courts are either reaching conclusions properly or accumulating contradiction that by making some sort of error. And right, the general notion is that a legal system over time gravitates towards stability by reducing the amount of contradiction. I'm not sure if that's...
So I'll just make a comment. There are several interesting questions in the chat, some of them very long questions.
Sure.
What we're going to try to do is to compile the chat in some form of document, and then in cases like this, we will invite you, David, or you, Bill, to write responses, which we will then put on the website of this week's program. So we have a few more minutes for some more questions. So Olivia, do you want to go next?
Yes, please. I enjoyed your talk. Thank you, David. However, my original question directed to Bill still stands, specifically in the 6th and 7th.
We're losing you, Olivia. Can you put your
areas
question
of your can you hear me all right?
Now we can.
Okay, good. I'm sorry. My connection's quite inconsistent. Anyways, so the target and the effect are the areas I was concerned about when I asked Bill about what to do concerning the mental entities that are legal, right? I think that the target and the effect are like unfortunately going to depend on the people with the relevant legal roles at the time, right? Especially when you make such statements as, you know, the effects of whether the law is enforced as it's supposed to, or something like that. You know, that's my question is, you know, who decides really whether a law is enforced as it's supposed to?
So legal orders, as I think I mentioned in the chat, generally have a rule adjudication system. So ours does too. For instance, the ultimate arbiter is the Supreme Court, and they do so in reference to the Constitution. There's no other mechanism for doing that in our order. Now, other systems have some other authority that sets the rules and determines whether or not the courts have abided by them. But it's not always documents. So, for instance, in the common law system in England, this wasn't institutionalized in any constitution. It was the general recognition structure of the courts and those who abide by them that creates that authority.
So Lauren, would you like to go next?
Sure. So really interesting talk, and thank you. so we work on the the side of having to take action. And so what I understand to maybe be happening here is that there's a legal ontology that backends things, a reasoning layer, and then we're in the space of ODRL and Prov and Pravo. So we need to kind of have, or we'd like to have, machine actionable contracts or agreements. And we have to work across legal jurisdictions. So we work with the Francophone, Anglophone, and Lusophone Africa. And we have to think about really different legal structures, legal basis. And I'm just curious, like, if you or one of your colleagues is working on the space of trying to connect, the provenance and the upper legal ontology, and then downstream ODRL, or if this is anything that makes sense to you, I guess.
I think there are numerous people working on that. I'm not working on that, so. But I'm sure there are a number of groups. I only consult with like individual groups who are working on their own legal ontologies.
Okay.
Can
I just
close on
just real quick thought.
2 seconds. 2 seconds.
2 seconds.
There is a mapping already between basic formal ontology and Pravo that was published recently. So there's already that connection. So anything that's extending now from BFO already gets some semantic inheritance. I've got a lot more to say about the broader ecosystem. Happy to do that, but Bill, go for it, man.
Yeah. So this was one slide that I should not have left out. Can you see my base schema here? Can you see that? So what I'm saying is most of the written law, so this example here, is not prescriptive, right? So we get down to those individual clauses, and you can see that here in the US code that we have designators like the titles and the sections, and then we have definitions in there of what a crime, what an assault is, and then really there's only a few clauses in this one that are prescriptive. And my claim is that we have to get, that was my earlier claim, that we've got to like harmonize those three efforts.
You're not sharing anything except the conclusion slide.
Oh, good Lord. All right. Sorry about that. Let me bring this over. It's right here. There we go.
We don't see it.
Not quite, Bill. Now we have the bamboo again.
Okay. Let me try that one more time. Share. Okay. Now do you see my schema?
No.
Just see you.
Now we see your spectacles.
Oy. Okay. Well, I can't make the point without this. All right. Never mind.
So let me make a point, which I think Bill will be involved in backing up at a later stage. So part of the role of this meeting, this whole week-long meeting, is to identify areas where the powers of BFO can be put to the test. And I think that Lauren's problems, which transcend any single legal system, but which at the same time are problems which we can recognize are problems of interoperability, of just the sort that we've resolved in other areas. So we should identify people who want to work together to solve these problems. And so I would be happy to mediate between Lauren and David and Bill, and to identify other people who are have more expertise in the provenance side of things. I know that we have other people on this call who are interested in comparative legal systems. And I don't think he's in the room now, but we have somebody from the World Bank who's working on those kinds of questions. He was in the room earlier in the day. So do you think that's a good idea, Lauren?
Yeah, absolutely. Because we think of, I work on pandemics, very cross-national.
Yeah.
So we have to think about how can we do these things in different kind of legal conceptualizations, let's say. And so I think that would be really, really nice. And I think the provenance side is often left off, right? So the provenance side, and then what can you do? What can you not do? So I thought that sounds fantastic. And from my side, I bring the folks from ODRL and Prav and the legal hypergraph folks. So what do you do when things don't align? How do you take action? What do you do? It would be very interesting.
So I can't remember whether it was Bill or David who said this, or maybe I just dreamt it. But I seem to recall one of you saying that we already have computational systems which are working well or working successfully with legal documents. I don't think that's true. I think that the ways in which people are working with computers in regard to legal systems are actually very poor and very fragmentary and very Western oriented.
No, I wouldn't suggest they're working well at all. So I've had groups that are trying to build systems that will understand insurance documents come to me with systems that they built off of existing work that are utterly nonsense, unfortunately, and doing the wrong thing, and that will get people in trouble. So we had to strip it down and start over.
Yeah. So what I think, can you now see my schema there?
No, we still have the bamboo. It's quite pretty.
I'm sorry about that.
Don't worry, we only have 2 minutes. Now we can see your schema.
Okay, so my point, and this is what Olivia and I found when we were comparing those ontologies, is that you see the structural entities on the left, and we want to be able to reason about those, but you also have the content entities, and you got to get through the title and the definitions of what they mean by an assault before you get to any sort of prescription. Right? And this is not worked out. And as a matter of fact, we have competing camps. And what I'm saying is we need to work this out and get it consistent.
Okay, so very quickly then, we already know that Lauren is interested in this project, and I'm assuming that David and Bill, you are interested in this project. So anyone else who is interested in working on this challenge should send me an email, and I will then establish some kind of a work group to work out what our problems are and begin to look for solutions. And we'll meet again in 1 hour.
Yeah, we're going to go have lunch. You go have lunch or do whatever you do, and we'll see you back for a discussion on modeling systems.
Okay, so I think you should be able to see my screen and you should be able to hear me okay.
Hi, Joe.
Hey, it's good to see you all. I was listening in a little bit this morning as well, and I was really enjoying the conversation I was hearing. Okay, so my name is Joe Gregory, for those of you that don't know me, and I am an assistant research professor at the University of Arizona. And as an introduction to this session, really, I'm going to talk very briefly, just 5 minutes or so, about why I'm interested in ontology and why the International Council on Systems Engineering, or INCOSE, are interested in ontology, and in particular, why they're interested in working with the Industrial Ontologies Foundry, the IOF. And the first thing I want to draw attention to is the fact that my background is not in ontology. So my PhD was in aerospace engineering, and I have been working for the past 4 years as a systems engineering researcher at the University of Arizona. And in particular, I'm interested in digital engineering. So this is the use of connected digital models, data, and tools to support the design of complex systems. And so this can include driving simulations. It can include assessing system engineering project status. It can support reasoning over incomplete data sets to support decision making. And the issue that needs to be overcome, and this is what I spent my PhD trying to overcome, but I was trying to do it without ontology, is the challenge of addressing the silos that we have across multiple tools within the environment. So software have their own tool set, electronics, aerodynamics, mechanical, and so on. And so we need to be able to connect the information that we have that lives in these tools in order to support those capabilities that I mentioned. And so towards the end of my PhD, I realized the importance of using some kind of shared semantic layer to improve interoperability between tools, different schemas, different modeling languages, and this kind of thing. And that leads into what I've been working on for the past 4 years or so. So I've been working on the implementation of ontologies to support engineers that want to do digital engineering. And so with my University of Arizona hat on, this has meant the development of a digital engineering environment that is supported by ontologies, in which undergraduate engineering students can complete their courses. So the kinds of questions that these students are interested in answering as they work on their engineering projects are things like, does my verification plan have full coverage? Are all of the engineering requirements going to be tested and verified? Can I trace a design component through my system architecture to a stakeholder need? So does every element of my system design serve some purpose? And so to do this, we know that we need to define certain classes. We need to define system, we need to define function, we need to define stakeholder need, we need to define requirement, verification activity, and then other processes related to systems engineering as an act. So things like integration. And then with my INCOSE hat on, I've been the co-chair of the Digital Engineering Information Exchange Working Group for 3 years or so now. And in particular, I lead the DEX Ontology Working Group. And we've been interested in addressing ambiguities in digital engineering terminology to support the systems engineering community. And so the kind of questions we're interested in answering is things like, when can we treat an artifact as an authoritative source of truth? So a really important question for exchanging digital information within a digital engineering environment. How do we create and maintain a digital thread? What are the key components? And so similarly, we have a set of classes that we are particularly interested in defining, things like digital thread, digital twin, authoritative source of truth, digital engineering environment versus digital engineering ecosystem. What's the difference? They tend to be used interchangeably. Is there a difference? Are they the same? Are they interchangeable? So we're trying to answer all of these questions. What does it mean to do governance? What is an active configuration management to support the work that is going on within INCOSE to enable digital engineering? But with all this in mind, we didn't want to start from scratch. And so this is where we picked up on the work, both from a U of A side and an INCOSE side. We wanted to pick up on the work that was ongoing within the Industrial Ontologies Foundry. And in particular, we've been leveraging the work that Jim Logan and team have been doing with the IOF Systems Engineering Working Group, and Jim will talk about that shortly. And so we've been working together more and more recently, and now we're at the stage where INCOSE have really started to notice this need for this shared formal representation of systems engineering. What does it mean to do systems engineering? And we're seeing it across the INCOSE and the systems engineering community more broadly, is that there is a kind of growing demand for this formal understanding of systems and systems engineering. And as I say, we know that the IOF Systems Engineering Working Group has been working on this problem for some time. And so INCOSE is now at a stage where they want to support this work, and they want to work together with the IOF on examples and demonstrators. And crucially, we want to present the value of this work to practitioners. So typically the people that receive the outputs of this work are engineers. They are practicing engineers that are working for engineering organizations. And what they want to see is the value that can be offered to them by implementing systems engineering ontologies, perhaps behind the scenes, or to support certain tools that they're working in. And so, as I said, that was a real quick 5-minute overview of why INCOSE, and in particular the Digital Engineering Information Exchange Working Group, is interested in working with the IOF, and why we're interested in this ongoing work regarding systems definition. I can stop there and we can do a quick changeover.
So, Christian, do you want to go next? Yeah, but you're muted.
Okay, not sure why that happened, but hello, everybody. My name is Christian Sprague. Thanks, Joe. That was an awesome recap of your project. And I'm the director of product at INCOSE. So I work full-time at INCOSE. I oversee their publications, technical products, development, as well as certification, and working with academics and practitioners alike on enabling systems engineering. And so, as Joe was saying, we are interested at INCOSE in partnering with IOF and all sorts of different ontology activities, mainly around enabling two different things. One is to build better or build systems better. So that's what Joe was just talking about. How do we do tool interoperability, modeling interoperability at the semantic layer so that we can enable better systems development, okay? Then the second layer, which I'll be talking about a little bit and will be presenting over at the IOF Summit here in a couple of weeks, which is around how do we enable better systems engineering? So this is one level up. This is more at the project level. How do we enable systems engineers to do their job better, not just build systems better? Yeah, so if you're interested in partnering with INCOSE or getting plugged in, reach out to me. I think my information will be on the last slide, but love to get you connected to our community. Okay, so this is at that level of enabling better systems engineering. So one question that we're very much interested in answering that we are currently working towards is around how much systems engineering does this project need? There's this big question around tailorability. Everyone has to tailor their programs. So from tiny engineering endeavors all the way up to massive, multi-system of systems kind of mission engineering battlefield kind of simulation or operations. There's massive decisions that have to be made around how do we implement our systems engineering? How do we develop the systems engineering processes that we're going to follow? How do we go about doing specification work? How do we go about doing verification work? How much verification do we actually need? How much specification? When we look at the ISO guides, 15288, how much do we implement? To what degree? So as it stands, the current state of practice is either by heritage, this is what we did last time on a similar project, by mandate, this is what the government requires based off their RFP or whatever it is that call, or by judgment, which is, hey, this is what our chief engineer says is how we ought to do our systems engineering. But we are very much interested in how do we codify, how do we to provide guidance, how do we enable systems engineers to understand? And I think ontology comes into this, and I'll show you how here in a moment. But for those of you who might not know, systems engineering in general is an approach. We think about ourselves as a transdisciplinary integrative approach that we enable the successful realization of complex systems. So that's how we're very much a method or the way we attend to the development of systems. And practitioners work within project teams, and we work to enable a completion of a successful system project. So this is why we can be applied to communication satellites, to insulin pumps, to national rail upgrades. So I want you to think, once again, this is at the project level. I want you to think about the fact that the artifact that systems engineers are working towards is within that overall project context, and therefore that the artifact is underdetermined to be able to provide systems engineers the guidance they need to know about how to do their systems engineering. So for example, let's take two artifacts from a large scale prime contractor, like an original equipment manufacturer who's been, maybe awarded a contract to do a geostationary Earth orbit comm satellite. If they're a prime contractor, they might want to do a full requirements decomposition down to the component level. They want to do formal qualification campaign written against a very well-defined spec sheet, staged review criteria across the different components, etc. Versus maybe you're a small stat constellation like the CubeSat mission or something. Maybe this verification is done by flight, meaning in operational context, or through trial and error. There's a continuous internal review rather than maybe staged gates. And they might be actually trading margins of error for speed. So there's this whole speed versus rigor trade-off that a lot of systems engineering programs have to make. And once again, that the verification might be largely done by evidence. So in what context should, or in what different project contexts or configurations do systems engineers do their work? So that's where these efforts are really around how do we structure projects? How do we think about projects? How do we think about projects in terms of their needs, their resources, and then the solution characteristics that our systems engineers are having to work within? So how complex are the solutions? So, and this is where the kicker is, and this is where I think ontology is really going to be a need, which is around morphological characteristics of these systems, of needs, of resources, of our solutions that we're building. And I can zoom in a little bit for Barry, which is around when we think about needs. You know, there are multiplicities. There's a cardinality of needs, right? How many? Are there single needs or are there a handful? When we think about the needs characteristics, are they heterogeneous? Are they one-dimensional, like make more money? Or are they multi-dimensional, like falling in love, right? Like there's lots of components there. Is there internal consistency? Are there trade-offs between the needs? Is there a structural dimensional typology of needs in terms of, are they hierarchically? Are there dependencies between the needs? Are there prioritizations? How fully determinate are the needs? Or are they more tacit? Or are they totally explicitly definable, et cetera? So we can characterize not just the morphology of projects, but also the modality or the types of activities and the mode in which engineers do their specification work. So I think ontology has a huge role to play here as we start to think about how to tailor systems engineering within the project context, how we characterize the project space, how we characterize the mode of systems engineering that needs to occur. And I think, I hope that there's some opportunity here. So if this kind of work is interesting to you or energizes you, or you're interested in working with INCOSE on these types of things, or IOF as we establish a partnership here, feel free to reach out to me. That's my information. And I'll kick it over to Jim.
All right. Thanks, Christian. That was great. Let me share my screen. And I have these silly controls. Okay. All right, so hi everyone. My name is Jim Logan. I'm the Chief Ontology Architect for the OAGI Industrial Ontologies Foundry, and I'm the chair of the IOF Systems Engineering Working Group. I'm also the CEO of a consulting company called Ontogenesis Solutions. So the IOF is an organizational unit of a company called OAGI, and the IOF ontologies, they get their most general categories from BFO. Our core ontology extends BFO with domain-independent industrial content, and then our industrial reference ontologies extend that content for industrial domains. Our ontologies develop the industrial ontology content, but not the bottom applications and data layer. So what do I mean by an ontology? An ontology is not another canonical data model or schema. Instead, it tells us what in the world models, data, and statements are about. So you can see on the slide here, materials, equipment, processes, plans, requirements, events. Those are the things in the world. So an ontology makes that account explicit, explanatory, and logically precise. And that supports interoperability because different systems can refer consistently to the same kinds of entities. So local models, schemas, and vocabularies are created for particular purposes. They can refer to a shared account of industrial reality without becoming one canonical data model or shared schema. So a foundry is needed to develop, standardize, govern, maintain all these great things about shared industrial ontology content that these different local models and systems can use. So the IOF brings cross-industry participation, BFO alignment, governance, review, maintenance, and publication to that work. The IOF provides a lot more than ontology files. It provides the IOF core and industrial reference ontologies together with standards, guidelines, examples and patterns, review and validation, versioning, publication. That's not just files in a repository. The IOF has been releasing ontologies since 2023. It's already completed nearly 4 releases just in 2026 alone. There is a new release under review now, and it's expected to be approved for release at our August face-to-face meeting. By the way, I think there's still time to register to attend that face-to-face meeting if you care. Provisional content is available for experimentation, but it's used at your own risk and may change substantially. Other content is under working group development. The IOF provides reusable relations and hundreds of classes across industrial domains, including supply chain, production planning, biopharmaceutical manufacturing, maintenance, and others. Every IOF working group combines subject matter experts, ontologists, and industrial problems and use cases. The result is reviewed, governed ontology content. These are example working groups, not a complete list. The systems engineering is highlighted because it connects directly to this session. It's one working group among several. The work of the IOF requires more than volunteer effort. Organizations that need shared industrial semantics should join the IOF, help fund the development and standardization work, and assign subject matter experts at least, and maybe ontologists to participate. Individuals can start now by examining and using the public ontologies. So as we talked about earlier, INCOSE brings an established systems engineering community, use cases, and digital engineering ontology work. The IOF brings a standards development process for governed BFO-based ontology content. We have an MOU under development, and we hope to work together. So the governed ontology standards are a potential outcome of this exploratory collaboration. And that brings us directly to the question for this session, which is, what is a system? So with that, let me turn it over to Barry.
Can you give me my... Okay, so a little bit of background. I worked with Christian some years ago when he was a student of systems, not just systems engineering, but systems science. And we talked about how we might represent system in BFO, but then we lost touch with each other and I became involved in other things. And it wasn't until Joe Gregory came along with his ontology proposals in the systems engineering world that we all started to work together to work out how we might represent system using BFO. Now, there are many things that BFO does not represent, but typically the relevant thing will be represented in one of the extension ontologies in the Common Core ontology ecosystem, for instance. But we don't have a good ontological representation of system anywhere. The representation in CCO is okay, but it's tiny. It doesn't build a basis for the kind of collaborations that we were just talking about. Now, we also don't have a representation of need in BFO, but we never saw any need for a need. But I'm going to propose now the beginning of a working example of what a system might look like in BFO by adding a small number of ingredients from BFO to our understanding of how entities work together, people work together, for instance. And I'm sure that this is going to be, if I'm right that this is a good starting point, it's going to need to be extended along multiple axes in order to do the kind of work that INCOSE and IOF need. In particular, it's going to need. But need is only one example. So let me start. I'll try and do this very quickly. I realize that it's very preliminary, and I'm hoping that you will kill it or knock it down from its pedestal. All right. So I'm going to talk about the family. INCOSE focuses, for obvious reasons, on engineered systems. But I think the word system is a wider term, which includes also natural systems. And my ideal for the BFO definition of system is that it will refer to both natural systems and engineered systems. So I see organizations as systems, football teams are systems, an engine is a system, but an entire railroad system, the Long Island Railroad, for instance, is a system. And the solar system is a system, but the decimal system is not a system. And the Library of Congress catalog system is not a system. So systems are always material entities. That's a fundamental criterion which is shared or satisfied equally by both natural systems and engineered systems. So we have a father and a mother, and both of them have lots and lots of acquired dispositions. So they can speak a language and they can boil an egg and so on. But we don't have any system here. We just have elements. And also, because they are adults, humans, they have lots and lots of roles. So the father is a conductor on a railway. The mother is a president of a charitable organization, and so on. So there are both dispositions and roles all over the place, some of which connect the father and the mother. For instance, the father might be the husband and the mother might be the wife. And we hope that they are something like that. And they are roles. So we have both dispositions and roles. And these are the two prime starting points in BFO for understanding system. That's my claim. So then being married is an acquired relational role, but there are also acquired relational dispositions, such as love. Love is an acquired relational disposition. And so is hate come to that. All right, now they bring a child into the world, and similarly, the child has lots and lots of inherited, somewhat fewer, but still it has acquired dispositions. It loves its mother, for instance. And they have monadic dispositions and relational dispositions. So the monadic dispositions are to get up in the morning or to run around the house. And I don't need to talk about that. So, and they get realized, these dispositions. They do get up in the morning and they do run around the house. So we have now realizations of monadic dispositions, which are the yellow things down the right. And so now we have here elements and we have relational dispositions. And now if you look at the INCOSE definition of a system, it starts somewhat along the following lines. A system is a collection of elements which interact. Now that's, I won't say it's wrong because it's actually a good starting point, but this is not a system. Even though we have a collection of elements, namely the table and the pen and an interaction. To have a system, you need more than just elements and any old interactions. You need at least interactions which are relational dispositions. So if the pen was somehow, because of some built-in drone facility, if it lands on the table every time anyone speaks in the room, that might be the starting point for a system because we have a relational disposition between the pen, its software driven interior, and the table. Terrible example. So relational dispositions get realized too. The disposition to nurture the child gets realized in the nurturing of the child. And a lot of this was already seen by Ingarden, but I won't talk about that. I will have more to say about Ingarden on Friday, though. All right, so we have these relations, which are relational dispositions. Interaction, what we need is interactions between related elements, where the relations come through the interactions. And then chimps nurture their children. So we're not just talking about human beings when we talk about the relational disposition to nurture a child. So chimps do a lot of it. And humans, their relational dispositions have an output, which are children, which over time become nurtured children because they have acquired relational dispositions from their parents through their upbringing. So systems can have outputs. And now note that everything on this screen is a continuant. It continues to exist. We don't have any processes yet. Processes are the realizations of roles and dispositions. There'll also be the realizations of need, but we don't need yet. But now the children have dispositions of their own, and some of these will be instincts. So children of birds have only instinctual dispositions. They don't have any learned dispositions. And some of the dispositions will be imprinted dispositions rather than nurtured in the human sense. All right, so both roles and dispositions are realizables. Roles are the product of assignment. The priest marries John and Mary, and they thereby acquire the roles of husband and wife. This is a very old-fashioned view of marriage, but never mind. So roles are the product of assignment, so they're independent of physics. They're independent of behavior, but they're not independent of authority and law and all of those things. Dispositions always go hand in hand with the physics of the bearer. You can't gain or lose a disposition without changing physically. Realizing a role now, once you have the role of being assistant cleaner in this factory, you will very quickly acquire dispositions to use a brush correctly. So that there are tight connections between roles and dispositions. Now, the grand claim that I'm making here is that those tight connections and the general framework of relational dispositions and relational roles are enough to give you system. All systems can be accounted for. And this is where you can shoot me down by finding examples which don't work. All systems can be understood as collections of elements, sometimes collections of subsystems, but that just moves the question one level further back. Collections of elements which stand in relational dispositions in the case of natural systems, and roles in the case of all the various different kinds of artificial systems, such as engineered systems. All right, I won't go through the Japanese way of dealing with relational roles. I'll start here. So the mutual dependence means that we have really one thing here. It's just that my drawing skills with PowerPoint are not, as you can see, I'm pretty crappy at doing these things. But we should be able to build one diagram which makes the mutual dependence more evident. But this is one system. It's the entire family system comprehending both roles and dispositions and interrelations between the elements and interrelations between the roles and the dispositions. And these are being realized over time, which will create even thicker interactions between they'll have more children for a start. So this is a very, very simple diagram, but it's the meat and potatoes of what will over time become a very, very, very complicated diagram. So you end up having financial roles, medical roles, legal roles, and all of the dispositions which go hand in hand with those things, for good or ill. And so I will illustrate. So in the end, it's going to be a mess. I'm not going to be able to do justice to it, but it's going to be much worse than that, which is a systems engineering diagram. It's a very simple one. Typically, they are very complicated. And this will be very complicated if you do it properly. Maybe for a marriage guidance text for an LLM. I didn't say that. All right. So now Jack and Jill take out a mortgage, and so they acquire a relational, it's a joint mortgage, so they acquire a relational role of being a mortgagee. It is a mortgagee, and the bank is connected to Jack and Jill through this relational role. So the bank is a bearer of this role. But the way in which they bear the role, the ways in which they bear the role are somewhat different, because the bank is more targeting Jack and Jill, where Jack and Jill are benefiting from the relational role. And so being in this relational role means that they acquired a new disposition, which is to repay the damn mortgage. And then the bank acquires a new disposition to punish Jack and Jill. They have to come to the bank and explain and be stared in the face and all those really cruel things we do. So that's a new disposition on the side of the bank. And now haven't worked on co-bearer yet. Whether they both have to be punished at the same time, I don't know. But now the bank can't punish Jack and Jill by killing them, and moreover, it can't get punished for punishing Jack and Jill, providing it punishes Jack and Jill within the bounds settled by authorities. Now we get a legal dimension. So the bank is part of a banking system which protects its role in such a way that it allows certain realizations of the disposition D to punish Jack and Jill if they do not pay. So here we have a bigger system, which includes this bank, this relevant banking system, which sort of is off screen, but it's much bigger than anything on the screen. And then Jack and Jill, who are targeted by the bank in a good way in the beginning, and perhaps always in a good way. All right, so all of this works for organizations and offices, and I think that's it now, so I will stop. And anyone can speak. So.
Question.
Yes.
So you said that there would be that when you take on a role, you take on new dispositions because you took on that role.
Typically, yes.
So is there a scenario in which you take on the role? You don't have those dispositions for some reason, but you still have the role.
Yep.
Like, are you given the role as a painter? I can't paint, but I still have that role.
That's not a very good example, but if let's say you're a lawyer, you get your legal license, it comes in the post, but you had it already since midnight, but you didn't change physically at midnight. You get your legal authorization, you are now a lawyer. A lawyer in every sense of the word, but then you have a brain hemorrhage, and you're out of it until your retirement age, and then you come back to life and you are a former lawyer. You still were a lawyer during it.
Makes sense.
People are strangely quiet.
Barry,
Yes.
can you hear me? Can you hear my voice?
I can hear you, yes. I just didn't see a hand, but maybe...
Sorry, I skipped the step because there was...
Okay, never mind, I'll manage.
I asked the question in the chat, but I'm going to get to it in case you haven't read it. So very thought-provoking. I was just curious, how would you contrast your realized dispositions as compared to the formal requirements that we typically capture that must be realized, right? Most of the requirements that we have, we write them so that we can realize them and we can cross-check if it met the requirement, right? As we implement the SE in a
good
domain.
So I'm tempted to say we haven't required requirements, but clearly in order to do a good job in doing justice to engineered systems, we need to have requirements built into the ontology. And I would suggest that it would go along something like the following lines. Your system is a Mars mission system, so you need to have trained space cadets, or I don't know what's the word.
Astronauts?
Astronauts, that's the word. We need to have trained astronauts in order to get the spaceship to Mars. And so we need to hire trainers, and those trainers need to have certain qualifications. That's a requirement. What does that mean? Well, first of all, it means they're going to have the certificate, which says, I am trained to teach astronauts. But then also they need to have proven their abilities. They need to have proven the benefits that they bring in their training. And so there will be requirements which say the holder of this particular relational role, which is now an office or it's an opening in the system. It's not an element of the system. It's an opening. And we've worked a little bit on that when it comes to organizations where people go on holiday or die. So there is an opening here for somebody to occupy the relational role of teacher of the astronauts. And that relational role comes with requirements which are stated, which have to be satisfied for any person to occupy or have that relational role. So very often you can think of relational roles as offices in an organization. For instance, the office of being president of the United States is a role. And it's a role for which the opened role, the bearerless role problem doesn't arise, because as soon as one president dies, another president comes into existence immediately, and there's no gap. But if you're a pope, you have to worry about that for a time, when you die, there will be a hole in the system. But there's a pretty detailed requirement set for that particular role. Yes.
Is it a necessary part of a system that the elements of that system have roles? Because if I think about the planets in a solar system, it doesn't seem that they have roles. They only are disposed to move in certain ways according to one another.
Yeah, exactly. So my view is that natural systems only have dispositions. So a chimp family or a pigeon family only have dispositions. But as soon as you have what in the larger senses could be called an engineered system, or a device, engineered will work, then you're going to have, actually it probably won't work in the end. Probably we're going to need a word for those systems, like a legal marriage, where we have roles as well as dispositions. And I don't know what word that would be, but organization might be organizational systems would sit side by side with engineered systems. They both have both relational dispositions and relational roles as the vehicles which relate the elements in their interactions, in their systemic interactions. Those are their interactions which are relevant for their being part of that system.
Does this account apply to complex systems?
So this was the one criticism I had earlier of Christian's presentation, because he said that we can use systems theory in order to engineer complex systems. You can't. You can engineer complicated systems, very, very complicated systems, but you can't engineer a complex system because of all the reasons we give in this book called Why Machines Will Never Rule the World.
What underwrites complex systems if it's not dispositions
and roles? Oh, it's dispositions. No. So all right. So some complex systems, in fact, probably. Oh, I'm getting into trouble now. So human beings are complex systems, and therefore, when human beings join together to make organizations, the organization itself will be a complex system. So the U.S. government is a complex system. The U.S. Army is a complex system. INCOSE is a complex system. But we don't engineer any of those, really. So it's a harder problem than I had anticipated 43 seconds ago. But what? It's dispositions all the way down, unless you can show me a system which cannot be unpacked using just relational roles and relational dispositions. Disposition is a very, very broad. It includes function. It includes capability.
This point about complex systems that you raised in the book is specifically on this, because disposition realizables the targets of scientific inquiry, like the things that we can find as explanations for the phenomenon.
Okay, so I'll have a go then at solving my own problem. Can I have some water? Is there any water handy?
Hey, Barry, can I ask a question?
Yeah.
Yes, we'll have a question while I find some water. Is this Alican?
This is Christian.
Oh, it's Christian. Yes, go ahead.
Yeah. Hey. So a few things is around engineering versus design versus intentionally realized systems. I think that there's lots of ways to qualify system and the kind of system we're getting at. I do think that point raised earlier, I don't remember who said it, but around naturally occurring systems versus these intentionally I think in the chat I saw teleological systems that we've created with purpose, right?
Yeah.
And the infrastructure around the realization of that system, I think that's where specification comes from. That's where verification comes from, and validation and delivery and the manufacturing and the scoping and the provisioning of those resources, et cetera. So I think that there's that could almost be thought of as a system of systems if we want to stay within a systems context, or that's where I think that the project language comes useful and realizing these systems, or that there's some sort of infrastructure around the realization of these.
Yeah, good.
And then the other thing I was going to say is systems engineers are very loose semantically with their use of complexity, like complex systems. So I don't know what I said that gave that indication, but I think system scientists—
You use the word complex.
Okay, yeah. So in a systems engineering audience, like they use that word
I've forgiven you, don't worry.
Yeah, okay. We need to move on. So
all right. So Christian is right that there needs to be an infrastructure. So it goes like this. I mean, I think there are two kinds of infrastructure. So we have the family system. We have 6 kids, 2 parents, but all the grandparents and so forth. They all form this family system, and they all have mortgages and so forth. It's very complicated. It's also complex because they are human beings, and so they do all kinds of crazy things and different things, and things which make things more complicated than they otherwise be, and most importantly, things which are not predictable by any stochastic AI. Now, but we don't want to tether families to a very narrow, rigid set of behaviors so that they would be merely a complicated system. We like the variety and mess that is produced by families. But when it comes to organizations like the astronaut crews and the ground station personnel for a Mars mission, then we do want to tether the human beings involved so that their behavior falls within the requirements set which has been formulated. And I think that really does occur, that people's behavior gets tethered by rule. We all religiously behave ourselves when getting into this building. We don't sneak in.
I think if this is the line, though, you're giving too much grace to how folks operate.
How?
Christian just said how loosely they speak of systems. Researchers, we want flexibility there too.
No. Okay, that's the other dimension. Yeah. So no, I don't want grades. I want just 2. So when do we have a system? So in one sense, the solar system, it's been around for a long time. So we didn't have anything to do with it being a system, but there is a sense of system which I think is something that we should take account of. And this was part of the conversations I had with Christian long ago, according to which a system is a selection. Mm-hmm. So my job is to check that the astronauts have the right food when they're training. They have to do that for years to be ready to be, how long is it? 14 years and then they come back. So the system I'm focusing on is the feeding system for the astronauts, which is much narrower than the family system and so forth. And that's true in science too. We can't, if we want to understand how the digestive system works, it's not good to look at all the ions in all the molecules in all the cells of the digestive system. You have to look at a larger granularity. So a system, in very many cases, is the product of a focused delineation, mm-hmm. or a focusing delineation, a fiat delineation of a certain granularity or a certain set of granularities and of a certain environment. So we're not interested in other Mars missions. We're only interested in this one, and so on. And so once we do that, we eliminate all sorts of complex system possibilities because we focused just on this particular kind of molecule. And the protein folding, protein folding, they didn't solve it with AlphaFold, but they solved it for certain proteins where the solutions had already been created by human beings.
I can keep going, but I'm gonna look.
Okay, Ali can.
Yeah, I was actually going to ask about the fiatness, the boundary of the system specifically. So that if I had tasked with what is the digital twin, which was asked for me, and then I worked on that, so like looking at through like a different digital twin project, so to say. And then what I observed is that if you look at the particulars of what these systems are, they are not quite same, so to say. Yeah, there are some similarities, but if we ask the question, what is a digital twin, so to say, we cannot go from the particulars to the what the digital twin is as, for example, are we going to say that it's a universal as the other things? If we say that it's systems, we put it in the BFO, or is it something like a defined, or in the case of the fiat boundariness, like how can we really actually handle this problem? So you actually spoke of it, but that's what I would like to ask the individual. And
Okay, that's a great question. So I believe that the first step towards answering your question would be to make the suggestion that when you make a digital twin, you're making a selection which is in some ways analogous to the selection that you make when you pick out a system. The difference is that the selection is on the digital level rather than on the system level proper. And I want to add one thing to what I said a minute ago about selection. We create the system, not the digital twin, I'll come back to that, the system by selection. But what we create, even though we've selected it, it existed before we selected it, and it will exist afterwards. So, and this is very important, the family will get bigger, there'll be more babies, so the system changes. It's still the same system that I picked, namely the family system around Jack and Jill, but it's now grown bigger, or it dies, or something. Jack dies, and the system changes immediately. It's still the same system because I want to follow this family. But if I say, if this is now completely different, my old system approach, my original delineation doesn't work anymore because Jack is no longer part of the family and so on. We need a new system. So that's important. Even though systems are products of delineation by scientists or administrators and so forth, they are nonetheless, they have legs of their own and had legs of their own typically before the particular delineation takes place. Now, the second aspect of your question, Ali Khan, has to do with the digitalness of digital twins. And I don't want to attack John, but he's been chortling in the background. Anyway, so I think that BFO is doing a rather poor job on addressing the ontology of digital artifacts. And I think that that is a different job from the job of teaching people how to use digital artifacts in order to exploit BFO's capability.
May I?
Please.
So outside the scope of BFO, but in some of its widely used extensions like the Common Core ontologies, I'm leading various efforts exploring just the exploration of actual digital ontology content under a cyber ontology foundry, which we've kicked off, as well as in the general modernization effort around information content entities. So there are going to be massive changes coming out under Common Core in this vein to mature this space. So I agree with Barry about BFO not having enough maturity around this, but extensions of it will. And I do have a paper that lays out some of this on digital twins and how you should model them, how I think you should model them. It's a proposal on design patterns that actually adds content rather than, as Barry says, just teaching.
Good. All right. So will this work have an impact on the way we use generically dependent continuant?
For CCOs, it's specification of how, or one way to use generically.
Okay.
But it is in line with everything we discussed. So GDC is not necessarily about something, but there's a space in them that we're interested in that are. And then like more refined types of information
Yeah, yeah. So I don't know whether you talked about GDCs on Monday, but yeah, did you explain what it means? Good. All right.
And I told the anecdote of you naming it that because it's so ugly nobody would forget. And then you proceeded to introduce a class under called information.
So I will explain what GDCs are, just for those people who didn't hear John's original jokes. So a GDC means generically dependent continuant. The idea is that there are some entities which are dependent on other entities in order to exist. So, for instance, the novel War and Peace, in order for that novel to exist, there have to be copies. If there's just one copy left, then the novel still exists. But if all the copies are destroyed, then the novel ceases to exist. So the novel is generically dependent on the copies. And this idea of generic dependence is it's in BFO because it's very general. Wherever you have a copyable pattern, you have a generically dependent continuant. So the chessboard pattern, for instance, is a generically dependent continuant. Wherever you have copyability of some sort of pattern, that includes the genomic patterns, molecular patterns, there you have generically dependent continuants. And now the most common generically dependent continuants, of course, are things like PDF files, which have to have some kind of a memory, a hard drive, in order to exist. But they can be copied from one hard drive to another. So that's what GDC means. And as I say, it's in BFO because it's general, and information content entity is somewhat less general, but it's becoming more complicatedly general because of the rise of digital information artifacts.
Hey Barry.
Yeah.
Did you see that Joe has his hand up?
No, Joe, go.
Thank you. Thanks, Christian. So earlier on in the session, I copied and pasted the INCOSE definition of system into the chat. If I just quickly read out the definition for focus on the physical system, it says it's an arrangement of parts or elements that together exhibit behavior that the individual constituents do not. So this idea of emergent behavior through the interaction of elements is a critical part of the definition. I think you touched on this, Barry, but could you give a little more detail about how BFO might handle this idea of emergent behavior?
Yes. So I have two concerns. That when people talk about emergence, there are many different views, to the point that it seems to appear as a kind of religion. So you choose your view of emergence, and there's no practical way of picking out a good view of emergence. So I tend to avoid using the term. I would prefer to define it and then use the defined version. But my second concern is that I can't think of anything which let me. All right. I think it's trivial, but it may be trivial in a useful way if you can find a good way of expressing it. So this is not a system. If we just have the cup and the table, the cup is on the table. That's not a system. They're interacting. There are two elements which interact, but it's not a system. Why not? Because they're being one on top of the other doesn't add anything to the way they behave anyway. And so there's something that needs to be added, and so there are systems at the molecular and the atomic level. Yes, of course. Yes, of course. It's a natural system. Why not? It's hard to find all the ions, but you need very, very good eyesight.
This has more mass.
What they mean is interesting emergent property. I don't think that's an emergent property in any interesting sense. That's your job. You brought this one up. I was quite happy to coast.
Could I
All right, so yeah, go, Joe.
provide kind of the classic example? So if you haven't taken aircraft as your system and think of its components as being the wings, the engines, the flight deck, the rudder, the ailerons, all this kind of stuff. So when you look at those components, none of those components have the function of maintain level flight. But when you put those components together in a certain way and they interact, and you get the function from the engine, which is to produce thrust, and you get the function from the wings, which is to produce lift, and so on. You get the function from the flight deck to control flight surfaces. Together, you get this emergent function, let's say for now, of maintain level flight. And I wonder, this is where I wonder what the relationships look like between those system level functions and the component level functions that represent that kind of emergence.
Great. So that's very helpful. So functions are a subtype of disposition in BFO, and natural system. Do you agree with me that we want our definition of what a system is to include natural systems?
Yes, I agree.
Good. So so there are functions within the realm of natural systems. Your digestive system, a chimp's digestive system, indeed, has the function of digesting the food that the chimp eats. So there are functions in the world of natural systems, and there are functions in the world of engineered systems. Now, I think that a definition along the lines of a system is a collection of elements which interact in such a way that that this collection is able to realize novel functions. We have to find a better word than novel. That would fit. Capabilities might fit even better. Yes. Yeah, good. Capabilities makes it work better, actually, except we haven't talked a lot about the capabilities of plants, or but still, it's something I think we can crack. It's a nut, in other words. Okay, so now we have to stop, and it's someone called Break. Break is on there.
Hey everybody, we are at the exercise portion of the course for today. Got some interesting things for you to spelunk. If you've been tracking the GitHub repository for day 2, then hopefully you didn't get started early, because I made some changes like 10 minutes ago. So, new stuff, but here's what we're going to do. You're going to be asked, there's an exercise instruction guide in there, just like last time under day 2. You're going to be asked to construct a design pattern like yesterday. Like we saw yesterday, like you've seen today. I've given some guidance on what it should look like, roughly speaking. There's an example, not an image example, but a description example and a sample that I provided in the repo as well. I'm also going to have you read off from that design pattern an OWL encoding. You can pull up Protege to just read off, once you've spelled out your design pattern accurately, the relationships, classes, instances into OWL. You'll use the class add button. You'll use the relation add button. You'll use the individual add buttons in Protege. And if you don't know what I'm talking about, that's great. Ask your favorite LLM for guidance. Or there's documentation on how to use this. So you'll be spelunking a little, playing around with Protege. That's okay. But essentially, you'll be reading off the design pattern, following recipes that we explored yesterday on some very interesting and very challenging cases. And by challenging, I mean these. There's some data sets. We're going to be looking at actual data from the FAA in one case and from occupation code standards in the other. And in the first case, there are 4, by the way. You only have to do 2 of them, but there are 4 I'll talk about here. In the first one, you will look at this data set. You'll find a row for Airbus 320neo, Should sound familiar. And you'll construct a design pattern in AL encoding reflecting the content of these columns. Case 2, much more interesting, I think, for those of you who love a challenge. Same data set, you'll find a row for Airbus 321-111, designed to have a maximum not approach speed of 142 units in there. However, after 5 approaches, I will add to the data. An instance has obtained an average maximum not approach speed of 139. Your task, if you choose to accept this case, is to construct a design pattern AL encoding reflecting that. Or, another case, in the SOC structure definitions file, you'll find 3 SOC title entries that mention aerospace engineer. For this case, if you're interested, you'll construct a design pattern in AL encoding that reflects all 3 entries in their respective SOC definitions. Or, in this data set, which I hope I added, I'm pretty sure I did, you'll find 3 OC title entries that also mention aerospace engineer. For this, you will again construct a design pattern in AL encoding that reflects all 3 entries in their associated columns. So 2 of the 4 pick. That'll be part of the exercise. The other part is constructing definitions for the classes and relations and descriptions of the individuals that you add. So there's guidance in a document titled Guidelines for Writing Definitions in the repo. It was published by Alan. It's probably Alan Ruttenberg's, of his work. It's my favorite. It's just a walkthrough on how you construct good definitions. It's very good work. It can give you some guidance on what to do, what a good definition is, how it looks, where it fails, where definitions often fail. It's a lot harder than you might think. So if you have a definition, for example, of an aerospace engineer, you should look at that document. Think about what an aerospace engineer is. Also look in that data set and see if there's a dictionary, which might be a good place to start. Or search around to see if there are characterizations of aerospace engineers online that you might leverage. Or again, ask your favorite LLM for information. It's probably not going to have an easy time constructing the definitions of the sort that Alan is talking about in that paper. We've done some experiments on these. LLMs aren't very good at these refined definitions. So, 2 cases, pick your poison. Construct definitions accordingly for anything you introduce, and you can put those right in your through Protege in your OWL file using an annotation. You click a little button. I'll walk around if you need help, or again, you can ask your favorite helper. Click a little annotation button. It'll pop open some options. One of those options will be definition. You'll click that, and you'll start typing. With that, good work. Oh, and I should also say, at some point, I'll stop and walk through solutions so you can see what I'm talking about. You'll see the answers. Well, for the design patterns in OWL, Barry will tell you the answers for the definitions. Okay, everybody, we're going to pause. We're going to pause. We got 15 minutes here on the agenda left in the exercises. I'm going to walk through somewhat quickly some solutions to give you an idea of what I was thinking as answers, at least design patterns, which you can then just read off the OWL encodings. I do have somewhere on my repo, if you want to go do some spelunking, the actual OWL files. They're not in this repository, though. You're welcome to go explore because I'm lazy and I'm not going to move them over. Or you could just read off the design patterns that I'm going to show you here, and you should get the same answer. So then if we have a little more time after I get done walking through this, maybe we'll pitch some definitions Barry's way, and he can tell you why your attempts have failed. But here with that, so this is the first case. This is what I have for the first case. So I kind of primed you a bit to work through this one earlier when I was talking about Samantha and her design specification. But it's basically what you saw earlier. I used this is about only relation. So you've got the Airbus 320 in spec. It's about only this anonymous class. It's got continue. And here I'm just reading off from some of the columns. I chose these columns specifically so they didn't get too complicated for you. I mostly wanted, despite the complexity of this representation, I wanted to give you a bit of an easy task. So column C has a FAA model. There you see that literal description. You see column, I'm sorry, that was manufacturer. Column D is the FAA model. Then column E, the BADA. You also have reference to continuum parts exactly 2 here for the jet engines. There are 2 jet engines. This is a moment where you're going beyond the data and adding a relationship that is implicit in the data but not made explicit. But here it is. So has continuum part exactly 2 engines according to the spec. Now, of course, if the Airbus doesn't have that many, there's a problem, but it also doesn't align with the spec, right? And that's how we kind of track that difference. But in any event, or maybe that was column G, it's a fixed wing. It's got a certain length. It's got a certain tail height at OEW feet. Not sure what that is. Again, I'm not a domain expert, just describing the logic, fixed wing, etc. So just kind of walking through. And again, you can read this off into your OWL encoding. You've got an instance Airbus 320N. It's about only something. It's a jet specification. Whatever that something is that you're talking about, it also has these characteristics, has continuum part of exactly 2 jet engines, is subclass of fixed wing, so forth and so on. And it looks, if you were to write it out in Protege under types, under Airbus 320N Spec 1 as an individual, you just click this little type button here. It'll allow you to add class restriction or restrictions on the instance itself. You can just type out what you're reading off that diagram. And you see the purple, we've got, these are logical reserved vocabulary for mouths only, and introduces a universal restriction. And then you got and, this is conjunction, this is unioning. Exactly, this is at most and at least. So you can spell it out using alls and sums in the background logic, but for shorthand here, you can just say exactly and then put some number. You can put values to introduce individuals. So reference to, or literals, I should say. Is it literals? Yeah. So has model BADA value, literal, or string right there. More interesting, I think. This is the one where you're not just reading straight off of a data set. You are to some extent, but you're adding content from experimentation. So after 5 approaches, an instance of Airbus 331-111 has obtained an average maximum non-approach speed of 139. What does that look like? Well, it's going to have, this is the more complicated one of the pair of Airbus examples. It's going to have that move from the specification to something, or to something that's putatively about, right? So it's got that information side about an anonymous class. In addition, though, there is, as a matter of fact, an Airbus that's supposed to meet the spec in the world. So there's prescribing an anonymous class, and there is an instance of that class, Airbus 320N instance. It has a fixed wing instance. And what we're doing is we're modeling how that fixed wing instance participates in certain testing, which has parts that are processes and that are measured. Because remember, we're thinking about an average, and we're thinking about measurements of a part of a larger testing process. Those measurements adding up to some, or averaging up to some value. Go ahead and take your pictures.
Screenshot.
There we go. And then we have, so if I'm just building out from this left-hand side that says that are measured, these will have these GDCs, the generically dependent continuous, that are measuring the approach parts, those temporal parts. They're going to have values. You can do some magic and use Sparkle to do some calculations, or you can get your calculator out and sum them up and do the ratio or whatnot. Regardless, whatever you come up with for sparkling or your calculator, it should line up to this other GDC that is the average, that has a value of 139, that is about this test process. Now,
okay, can you
yeah.
hang on 1 minute?
Mm-hmm.
You say the test process is a temporal part of approach underlying part 1.
Mm-hmm.
Isn't it the other way around?
Oh, did I get that back? Yeah, it's a test part of, or has temporal parts. Is that what it should
should say has temporal
should say has temporal part. I did say I did this in an hour, all 4 of these in an hour before a tutorial.
Now we need to think about the all sum rule. So if the test
These are instances.
Yeah.
All sum rule doesn't.
Okay. All right. Anyway, the arrow is pointing in the right direction.
But you see, so not all of them.
So all five.
Those five, yeah.
All five.
Yeah, so it should, or I'll just change the relations from temporal
Yeah,
form
yeah.
to has temporal form. But so I will say that if you're like an operator looking at this example, or somebody who does this sort of testing, and somebody gives you this example, and you're like, I'll need to think about the average maximum knot speed and how do I like represent that information. I did this down at SOCOM, and there were a bunch of operators who would give this example too, and they started talking about turbulence and like the length of the like path, the flight path, and all the air and everything, which is really fascinating information, super interesting. And I made them slow down, and I was like, yeah, but look how complicated it is before you even get there. And they were like, oh wait, oh, you need to build in all the background information, because information, like machines don't know this stuff. So we built all this in because, again, as I said yesterday, it's so obvious, you'll forget it.
Yeah.
All right, so other one here, case 3. This is the SOC title entries that mention aerospace engineering. A different example, not the Airbus stuff. If you do some research or did a little digging on what these occupation codes are, you'll find some somewhat complicated characterizations of major groups and minor groups and broad groups and detailed stuff. You also see aerospace engineering coming up in different places under these groupings. Roughly speaking, I won't go through this, but this is what those characterizations in that data set are supposed to mean. And this is just background information, so you can suss out why there are different entries that have the same label, because they mean different things. They're indexed to different groupings of the SOC data. Broad and detailed occupation, for example. I put this in on purpose because if you're dealing with data modeling of this sort, you have to learn how to deal with confusing data. And you probably didn't do this, but here's a gotcha. You should always research your data set. Just because I didn't give you the information doesn't mean you shouldn't look it up. And there's a manual right there that explains everything I was just saying. If you didn't do that, you probably had a harder time than you would have otherwise. I foot stomped this because I've been on teams with really, really, really smart people, really smart people who have gotten into tizzies in their cleverness with other people arguing this or that about some interpretation of data. And I just look up the manual and I say, I'm pretty sure it's this interpretation, which cuts through all of their cleverness because there was an anchor. They just didn't look it up. Don't waste your time. You have to deal with confusing data, research. In any event, aerospace engineers in this data set. This is the description, the main one. Performing engineering duties, blah, 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 blah. I flesh out this aspect of the definition. So SOC code, it's a subclass of GDCs, specific type. There are all sorts of SOC codes. Do I have 1 minute?
No.
So we're just saying, okay, there's specific instance of SOC code. And this one, the aerospace engineering one that we're talking about, it's that pattern again. It's about only something that has a bare job role. And then there's this whole host of things that might be realized. So acts of articraft design, outputs of aircraft specification, or adaptability evaluation being the output of a report, or recommending being the output of equipment tests. And these are, of course, indexed reports. So indexed reports to that adaptability evaluation. So specific to aerospace, right? Because that's the code that we're talking about. And I just didn't have enough space to put all that in an oval. So this is not a violation of the all sum rule, is what I'm saying. SOC code, about only anonymous class, instances of which are bearers of some job role, which if realized or realized in this or this or this. That's what the blue's there for. It's the or. So this is my little convention of introducing disjunction. But if you go back to this definition, this is what's going on here. They perform engineering duties. They may conduct basic and applied research and adaptability of materials and equipment to aircraft design, may recommend improvements in testing equipment and whatnot. And say any equipment test is an output of some active equipment recommendation. So building all that in here as characterization of this data, this like description. Last but not least, aerospace engineer in the OC title entries. I put this one as paralleling the other. These are two data sets, not all of, or the two I'm talking about here for each of these examples, not all of which you'll see together. usually out in the wild. Even though they use the same labels and have some overlapping information, they differ in interesting ways. So you've got a bunch of, like, as I understood it, text value literals or descriptions of what's going on. So you've got codes, different codes, SOC code 1, 2, 3. One's got a label, aerospace engineer. One's got a label, aerospace engineer. One's got a label, aerospace engineering and operations technologist and technician. Blah, blah, blah. More annotations. Anything interesting? They all have the same code, has area code. There's a link between these data sets. They all have the same area code. They all have the same ONW code. Oh, it's time. But they have these different awk characterizations. They have differences among them too. So they're linked up to this other data set, although they're not always connected. They are linked up together, and you can spelunk your way through by finding where they're connecting the data as you're spelling it out. Da 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 da. Da 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 da. I'm having to move quick because I was just told I had time. But this here, you'll see, spelling out of GDC, there's a population, aerospace engineering and operations technologists and technicians, bearing equality, which is input to an active measuring. That in turn outputs into total employment information, which has a count of 9,060 and is continual part of the SOC code. Now, instead of taking questions, I'm going to post these. Barry and I now are going to debate each other. The claim on the table is AI could replace John Beverley. And I think you're going to say no, and I'm going to say yes.
Good. Well, you give the position.
I'll propose. I shall do this. So I'm gonna take up the position that this is true, that you could replace John Beverley for specific purposes, obviously. In many ways, I am in fact irreplaceable, but the ways that might matter to you, ontology engineering, clever thinking, modeling, teaching you, pedagogy, all that good stuff, working in this or that post and doing millions of things and not spending time with his family. Of course, AI can replace John Beverley in these ways. We just need algorithms with some combinations of crazy statistical, clever nonsense that folks are coming up with and throwing millions and millions and millions of gigabytes of data about until we uncover what we need to generate enough AGI to be able to do satisfactory enough work that John Beverley would do. So the threshold isn't exactly like replacing John in all his glory, but replacing John well enough satisfactorily for the various tasks he does, right? So I can write books, I can write algorithms, I can write code.
No,
talk,
no.
speak.
The thing is that you want to do all of those things, and you want to do them in a certain order and with certain highly differentiated independence relations. So you're willing to sacrifice time to do X because Y is more important. So you're making choices all the time about how your time is spent, how your capabilities are spent. The AI can't do any of that.
So?
Well, then the AI couldn't replace you because you couldn't do the work that you do without making all of those choices, which are contextual choices and often choices based on emotions and good and bad emotions, jealousy and fear.
You don't think you can train a bot that would react to various situations in roughly the same way I would?
So there are no patterns in your life.
There are many patterns in my life.
No, but they don't repeat themselves.
Greg just said he's done these exercises that I've posted 8 times by now. I'm a pattern machine.
Okay, you did it 8 times this week. How many times did you do it in the rest of your life?
Oh, pretty regularly, and also I make recipes, right? I'm a recipe type person.
That's another thing.
I create recipes so they can be reproduced.
The more you put your finger up the same hand, the more you defeat yourself in defending this objection, because each time you're doing something new. you are the opposite of a pattern follower. And look at the position you're in. Is there anyone else who's even close to your position? In so many different hierarchies?
Well, in what sense is the replacing being used here? So if you mean like literally AI sitting the way John's sitting right now, like, well, sure, but nobody could replace John, period. Like, no human could come along. I'm too cool.
Yeah, so therefore,
But
a fortiori, no machine.
But I don't think that's too high a burden for anything. If we're talking about impossibilities. Oh no, but like
chickening out.
No. I mean, but what sense of replacement? This is why I started off with replace well enough. Like react in the same ways, or predictably react in certain ways. If you prick me, don't I bleed? If you hit me in the foot with a hammer, don't I yell and chase you? Right? Like
I don't see the relevance of any of
these are
picking.
These are the things. That's a joke. But like writing books, writing text, teaching students, recording audio.
Do you think the books that the AI write would really replace a book that you would write?
I think perhaps it doesn't seem implausible. It doesn't seem as impossible as literally replacing me to think that with enough information, with enough of my writing,
information about your life,
well, not necessarily on my life, but perhaps if that's what's needed.
About the things you've read, about the people you've spoken to.
Yeah, all of the things.
Okay, so you served in the unique position of having studied under certain people in a certain order when they were doing certain things, and you guided that in your own way, and all of it was unique, that no one else had the opportunities that you had in the order that you had them, and no one else was therefore in a position to invent the things that you invented. And they were new, they were not patterns for which there is training data in the internet. They were too much, you're too original.
Fair enough. Could we take
so I win.
Hold on, no, I'm not done. Could we let's say baby born tomorrow. We take this baby. We hook this baby up with sensors. And like sensor vision and all this good stuff, like propriocentric sensors and all this good stuff. And they're feeding information just the sort that the baby would perceive, and they're getting all this, and they do this for their whole lives. Like all the information from the environment that I would have gotten, all these unique experiences, and we use this as training data, and we start running simulations alongside, and we start testing to see whether the bot gets it right.
The baby didn't do anything from the inside to determine what the baby would get next and so forth.
20 years, 20. I'm just asking, 20 years, 30 years. We're testing, where they're training and retraining this bot that's running alongside the human. If it gets something wrong, downvote. If it gets something right, upvote. Just like you would do with supervised learning, right?
So what is the exact scenario? You're going to have a
one-to-one decision output.
A John Beverley bot in the same room with you through your life.
I'm asking if you think this is possible.
No, of course not, because the baby has interests of its own already. The baby has dispositions.
So the bot has derived interest, right? Derived interest that, as a matter of fact, seems plausible, could match up one for one with the decision output
that
the
would be
baby
magic.
I mean,
no way
it's pretty fantastical. It's a pretty fantastical example, but I mean, you told me I was chicken, so I had to take the hard case. So this is the hard case, right?
Yeah, but you lose.
Oh, how am I losing? You don't see this as possible, that you could train a machine alongside with all of those experiences.
The baby, you as a baby already was full of emotions, full of dispositions of all kinds, and you can't create through proprioceptive sensors a bot that would have exactly those dispositions.
Is it really the feelings and emotions that are missing?
Yeah.
Is that the thing?
Well, they're the hardest thing for the AI to.
But is that really what's missing?
Particularly the hardest thing for anyone to claim that you could have an AI bot which had dispositions of that subtlety already from before it got any kind of sensor data.
You know, in many ways, I'm quite emotionless. But I'm curious. I am curious. I mean, I'm not sure. Like, you know, jokes aside, I'm not sure that emotions play as much, or necessarily play as much a role in what it is to be human as is being suggested here. You seem to be thinking that they're essential, and no robot, like the linchpin
I
is that
didn't
they're
say
essential.
just emotions. I said emotions and a whole series of very subtle dispositions,
Like phenomenal,
which every newborn baby brings into the world, and then they get more and more complicated with time, independently of sensor information. Although sensor information, particularly in relation to the mother, obviously play a big role.
And
but you can't imitate that, unless you're going to have a mother bot.
I mean, why not? That's where I was going. A mother bot with all the mother bots.
You lose squared.
It's an empirical question, though.
No.
What, all right. philosopher time. So why is that impossible? I don't see why. Like, and this is may not be.
We're talking about the
I'm talking about the
now.
motherbot and all the machinery and training. So what metaphysically is wrong with this? It seems possible.
So I don't know where to start. You're going to, how are you going to get the data to train the motherbot and the babybot? First of all, let's start with that.
Oh, where? Are you asking me where?
Yeah.
How
far from where?
Let's say we've got hundreds of years and thousands of years of studying the phenomena. We've encoded as carefully as we could with rigorous ontologies and inferred as much as we
need
could.
Training data.
Yeah, and this is the training data, high quality training data we're feeding our machines with about mothers, babies, and everything we can learn from, from the outside, but also reports, qualitative and quantitative reports about these experiences.
So one of the features of mother-baby interactions is the feature of touchingness. It's very touching to watch a mother and a baby interact. I think behaving in a touching manner is one of the more demonstrative examples of behavior which an AI system could not recreate.
Why not?
Look at Elon's robots.
That's a bad example. I'm talking about.
There are only bad examples
I'm making,
of touching behavior on the part of an
I'm
AI.
making the case about what's possible now, because you're saying it's not possible, and I don't understand why it's not possible. So lots of bad examples of try, but also progress. The bots that are acting now are terrible by human standards, but they're so much more advanced.
Did you ever call your bank and get answered by a computer?
I did, and I do remember what it used to be like, and it is better. And
After 70 years, they should be able to do a human, shouldn't they?
I assume so, and they are better now. I mean, they're getting better.
Yeah, but they're not even close.
But slowness isn't impossibility.
70 years they've been at.
Slowness isn't impossible.
$11 billion or something they've invested in.
Expensive isn't impossibility. These are not the same.
All right, that we should change. What's the next topic? I'll give you a draw.
The richer the ontology, the less you need a large language model. Which side would you like?
I'm going to say against. I'm going to be against that.
Okay. So you'll say Barry is defending the position that it's not the case that the richer the ontology, the less you need an LLM. And I will say it is in fact the case. The richer the ontology, the less you need an LLM.
Okay.
Would you like to start or shall I?
You start.
All right. I think the richer the ontology is, the less you need an LLM. Of course, richer being qualified appropriately. Not every richness is going to make it like make you need less of an LLM. But what you're doing when you're creating high quality ontologies is solidifying information, encoding, hard coding information into your systems that is true, universal in many ways, or holds throughout, doesn't need to be retrained, it's logical, it's formal. And that's the sort of stuff that your LLMs don't need to guess about. You're cutting out through the noise. So these statistical entities, these statistical architectures, lots of guesses going on. They're dancing around conclusions, dancing around outputs in these probability distributions. But if you can cut out some of that noise for them, you need less processing power, you need less or fewer prompts, you need less data to train them, and so forth and so on. And how do you get that? High quality data, i.e. high quality ontologies that are accurate to the world and accurate to the inputs and outputs that you're expecting.
So I have actually confronted this case in the real world. A couple of years ago, I think Bill Hogan. Bill Hogan was his team. He and his team were sponsored by NVIDIA at a time when NVIDIA was still a lowly, not very important company. They bought, or they gave the University of Florida 6 very, very powerful computers and 20 staff or something to work with them on using these computers. So showing that the computers could provide benefit because of the early LLM kind of work that was being done already at that stage. And the idea was precisely that if you have a rich ontology of medicine, then you're stymied typically by the fact that nearly all the relevant medical data is in free text form. And you can't apply the ontology because it's free text. And the idea of LLMs, of course, is that they enable you to convert free text into useful scientific, in principle, useful scientific information. And so if you have the power of the ontologies plus the power of the LLM to convert free text into useful structured information, then you would have the answer to the Maiden's Prayer. That the LLMs would give the ontology a much greater importance in an important area like medicine. So I would say the richer the ontology, the more you probably need to go to your LLM and make use of your rich ontology in the real world.
So you mean, so there's I think equivocation over need for an LLM here. So you're saying the richer the ontology, the more applications you can use the LLM for.
The more successfully you can use that.
And I was arguing, I was on the other, I'm just making sure everybody else on the call. And I was arguing insofar as you're like training, developing, applying in trustworthy ways, your LLM, the more ontology you have, the less you need to do that sort of thing. I think it is true. I agree with you that he's clever. I agree with you. I agree with you though that yeah, for sure, the more opportunities you have to use large language.
I'll give you that one. I'm feeling generous.
Well, I can go the other way though. I mean, the richer the ontology, I can argue against this. Even Bill's case.
Go on.
All right, the richer the ontology. I mean, I'll tell you why. It's the same old story. The same reason we have invested so much money in NVIDIA chips and statistical AI. It's because these rich ontologies actually siphon money away from real progress. We spend so much time trying to build them, so much time invested in building these like Baroque architectures that are fragile. That LLMs, I mean, why would we use those?
Okay, so this
high quality, we just have the plain text.
So this needs to be reformulated in the form, the richer the ontology within the world's BFO-driven ontology enterprise, then you're not wasting any money.
That's right. That's right.
The less you need an LLM. So what we need is not richer ontology stuff and richification. What we need is the better the ontology.
That's right. We need it according to a best practices tradecraft.
Which wouldn't waste money in the way some people waste money on ontologies.
And this is what we do, right? It's easy to build an ontology. It's bad to build a good ontology, or hard to build a good ontology. And what we're talking about here is richness is good ontologies.
Yeah.
And you know, Robert Horndorf has some work around this area.
Who?
Robert Horndorf. He's got some work in this area where he does some experiments talking about the benefits of having logically enriched with axioms, ontologies for training. And
is this recently?
It's somewhat recently.
Because I was talking to him about this, I don't know, 10 years ago.
Oh, this is more recent than that.
Yeah, okay.
I saw him the other day.
All right.
You want your next?
All right, what's the next one? To advance ontology engineering, OWL2 should be abandoned and common logic should be adopted.
I'll defend this. Okay. I'm assuming you'll defend.
I'll take the other side.
Okay, so we have this thing called the infectious disease ontology. And the infectious disease ontology, as you know, I think played quite a big role in the ontological response to COVID, because it generated a whole family of infectious disease ontologies pointing towards different kinds of infectious diseases, such as viral diseases and so forth. And the OWL monopoly or near monopoly in the ontology world meant that even though we had infectious disease ontologies with English language definitions which captured the biology of infection, as soon as those definitions were translated into OWL2, nearly all of the medically relevant information was eliminated. So OWL2 can only cope with binary definitions. There is one term in the infectious disease ontology, I've forgotten the exact number now, but it's the definition of that term is a 17-place relation. And a lot of medicine is like that. And with infection, there are lots of things involved. And so OWL2 is a straitjacket around use of ontologies for a sophisticated programming and reasoning in important areas.
Okay, I'll take the other position. I'll say not only should we not abandon L2 for common logic or other formalisms, I'll just drop it off like there, but we should to advance ontology engineering, we need to focus more on the use of L2, the applications, and the tooling around it. And this is, in many ways, is something I've suggested or was hinting at yesterday. So L2 is decidable. It's a decidable language. I won't talk about that because it's not as important as its simplicity. It introduces very basic formalism to connect classes to classes or create disjointness between them, identity connecting individuals and whatnot. It's not very complicated by design. It's and of course the design reason is for decidability, but it's so simple. It's so simple. That's the main reason to keep it. And common logic is not. Formal logic is hard. OWL2 is not a very complicated language, and people struggle with it all the time anyway. Machines struggle with it all the time anyway. And when we have people use OWL, we have to teach them or reteach them. We have to teach our agents again and again and correct them because, in general, thinking carefully, whether you're an agent or a human, is quite hard. OWL2 is like the lowest barrier. It's disjointness, it's cardinality restrictions. You can say something is related to something or only other things. That's already hard enough for most human beings and most agents. Common logic's expressivity is beyond binary. 16 place at least, n-ary relations. It's the full gamut. Not only that, but it's more expressive than first order logic. You don't have a division between predicates and individuals and relations. You can mix and match between them because the semantics is very broad. So you don't even have the traditional categories you'd see in natural language between like objects and predicates. You can blur those distinctions. And honestly, even as somebody who specializes in logic, it can be quite complicated for me or Alan, or somebody like that to think through the subtleties. I'll also point to some major organizations that have used more expressive common logic representations when trying to do ontology engineering and bore out the fact that I'm talking to now. Groups that have built formalisms around things as expressive or nearby to common logic, more expressive than OWL2, and had to rip APL and had to rip them out of their systems for great expense because every time they tried to model or train somebody to model or sent off their examples or domains to other people to model, they've came back terribly because it's hard to get the logic right. And so the minimum bar they found was OWL.
Now, did common logic play the role there, or was it something weaker?
Weaker than common logic, but more expressive than OWL2.
So what was it?
So you can construct formalisms out of OWL2 that extend like OWL-full, for example.
Okay, so actually I would prefer to defend just plain old first order logic.
Okay, we can do that.
And the point of plain old first order logic is that for, I don't know, 150 years, it's been the default logic for hard thinking philosophers. And it's very simple to translate English sentences into first order logic.
So I just want to tell folks the difference here so they know. Okay. So common logic is it's considered to be, it's an ISO standard. It's a family of first order logics. And so first order logic of the sort that Barry and I are talking about, it's a more restricted. So one of the examples that would fall under that common family. And this one you have predicates that have their own syntax and form and semantics, and they're separate from objects that have their own syntax and semantics and properties and relations. And so there's no blurring of that division. It also has an infinite domain. You can talk about an infinite number of things. It's very expressive language, first order logic, though not as expressive as common logic.
And it's very simple.
It is simple. It's simpler than common logic. It's simpler than
natural
modal logics. It's simpler than temporal logics or second order, higher order logics that talk about sets of things, or quantify over sets of things. So it's, as Quine had argued, it is probably it has the best meta properties of any logic without being too expressive or too inexpressive.
So I'll give you another example along the same line. So there was a famous medical ontology project in England called Galen, and it was led by a man called, do you remember, Alan something? Not Alan Rothenberg.
Not Alan Rothenberg.
Anyway, Alan something would always, he was a good ontologist for his age or era. And he didn't like me at all, but that's all right. I'm going to say something nice about him. He said that the correct way to build an ontology is to have your terms and then define your terms using first order logic in order to get clear about what your terms mean. But because you can't compute with first order logic without the help of very clever people who can do the right sort of manipulation of the right sort of computer programs, you won't get anywhere with computing. But the step through first order logic to get good definitions, he said, was an essential step. Do you agree with that, at least?
I think you can. So I think it's possible to get good definitions without going through first order logic. Neil Williams is a good example of this. So Neil is like an artistic, very clever metaphysician who can write good definitions and hates formalism, even though you could translate everything he says into formalism. This is like a running joke with him. But so I don't know that it's essential. I think, you know, a critical enough thinker can work without the formalism and do similar work. But I do, back to the point here. So even with first order logic, even here, like psych is an example of it being too hard. It's like modeling everything in the world with first order logic. But like think about
that was that first order logic with such bad instructions. So the translation of A causes B in psych is if A, then B.
Just ignoring a whole literature. Wow.
They probably don't realize there's something so absurd can exist.
Yeah. So that's false. For what it's worth, that's not a good translation. But I mean, first order logic does it allows for expressivity to cover a lot of natural language for sure, and it covers a lot of like phenomena
and of technical scientific language.
Absolutely, yeah. I mean, it's the language of the sciences. It's what mathematicians are raised on. They use set theory, which is foundation in first order logic. This is true. All of that's true. It's also too hard to do ontology engineering, which is my point. And the minimal barrier for practice, for actual implementing, taking a formal structure and feeding it into a machine. Like that's the nice little middle ground we're trying to hit. Mathematics is too sophisticated for what we're trying to do, integrating data. But we need something more sophisticated than natural language. And we need something that will bridge this human machine and machine interoperability axes. First order logic gets it wrong because it requires too much of us. OWL is a middle ground between the sophistication.
Okay, so we'll see what comes of it. But IOF, the Industrial Ontologies Foundry, has decided to go down both roads. So they have a OWL version and a first order logic.
That's right.
Which was my suggestion. So we'll see how they do.
Absolutely. And you know, to their point, I mean, just I'm a fan. There's this Gavel project that Fabian's running, right, where it reads off the first order logic axioms from ontologies that annotate classes with that sort of stuff and refeeds them into first order logic automated reasoners to do consistency checking. So those are more expressive, more powerful reasoners than what you'd see in Protege with Hermit, which is a description logic, which is the OWL2 logic sort of reasoners. So you can express more relationships, you can express infinite domains in these automated first order logic automated reasoners, and so you can kind of read off from what IOF is doing into this more expressive environment that presumably captures more of the intended semantics of classes and relations in the IOF ontologies. For sure.
So we're throwing a lot of names and so
I mean the point still stands.
This is obviously not very good from a pedagogic point.
Well, I mean, I'm about to rope it around because I still think IOF takes too long and it's too hard, and they build too many biases in to their formalism. They take forever to build those axioms. Forever.
We're getting there though.
Yeah, we've been saying that forever. Now,
we had 4 releases.
Earlier, you were taking slowness as impossibility, so I think I will pivot around and say slowness as impossibility. I'm skeptical.
I think that this branch of activity in the ontology world should be kept alive. I think the more we push on the computing side of first order logic, the more we will find out what is really possible with first order logic. And then the ISO standard it requires that every top level ontology, if it's to satisfy the requirements, should be presented in both an OWL version and a common logic or first order logic version.
And I wrote in the MLO standard that it has to have a common logic representation.
Okay.
Yeah, I'm on board with that. But I will say, I think you just conceded my point, because you said we should just keep this common logic area open for exploration. I was just defending.
I don't like the first half.
it.
I don't like anything about this anyway, but still.
I don't either. I'm actually a big
did a
fan.
good job.
I think we did. I'm a big fan. Like cards on the table. I don't think we should get up on OWL too, but I definitely think we should be aiming for more expressive language for sure.
And
let's continue. Yeah, good job. Fictional entities are real entities. They are GDCs addressed in books, films, and merchandise.
Yes, I don't believe this, but I will defend it because I know that you'll feel left out if you're forced to.
What does real mean? I do think they're GDCs.
Yeah, they're real. This wasn't me. This came in through the
right.
What he or she really meant is really. So are fictional entities really entities? That's what I'm going to defend. And I think that from what we know about the way people read fiction and talk about fiction and make films about fiction and have emotional relationships with fictional entities and so on. I'm not talking now about your AI lover. I'm talking about.
Oh my. Sorry. Excuse me. My wife's watching this.
So some people do fall in love with fictional entities.
Not me.
You can't fall in love with nothing.
Yes, you can. You can fall in love with the idea of someone who's not accurate. People do that all the time.
No, because people understand it.
I'm joking. I'm kidding. No, but okay. So you're defending the position that fictional entities are real entities.
Really.
That are not
really entities. They're not real, obviously, but they're really entities.
They're really entities.
They are in a zone beyond reality.
In a zone beyond reality. Yeah. Like GDCs.
Yes, but they're not GDCs. They're
not GDCs.
No.
Well, what are they if they're not?
Well, he says GDCs. That they, or she.
I mean, I think they're GDCs. I think there's an interpretation of them which I'm defending, which is that they are GDCs. So when I say Superman, I'm talking about information. It's about something.
What is being said here with the really on the first line is that. Let's say that they are GDCs. They're not GDCs like information entities. They're not GDCs like gene sequences. They are a third kind of GDC, which exists because there are fictional works and readers of fictional works. And those readers, and this is what Ingalden says, those readers of fictional works create in their minds the fictional, the world of the fictional object, which includes fictional entities, characters, cities, and so forth. And that's what we read about when we read, and that's what we fall in love with when we read novels and fall in love with the main character, which happens, I'm told.
So when I fall in love with Catwoman from my reading of DC Comics, Superman, when I fall in love with this fictional character, 33, fall in love with this character. Is it right to say that I'm falling in love with this idea that I have?
No. Now you're making the same mistake.
No, I'm just asking.
The early ontologists made when they said that ontologies were about concepts.
Well, what is the thing then?
You can't fall in love with a concept.
Well, what's the thing then? I'm just trying to catch what it is. So I've learned it, like Tina and I talk about Catwoman all the time. I read about it in literature. I saw the movie with Batman and Catwoman was in it. I saw the bad one and the good one. And I got all this information. It's in the zeitgeist. Everybody knows. I just mentioned Catwoman, everybody laughed. They know who I'm talking about, like roughly speaking. What am I falling in love with?
You're falling in love with a fictional entity.
Mm-hmm. But it's like informed and influenced by this sort of conventions that we've all adopted about the use of this expression to capture something.
The expression falls in love with
Catwoman, right? Like this name,
yeah,
Catwoman. Yeah. And I've got this idea that it's formed by my reading and the back and forth I have with other people.
So the Ingarden's point is that if you're dealing with real literature, I'm not sure if Catwoman counts, then the readership has a common, they concretize in a way which is similar across whole population. And so what they are creating thereby is a concretization of marks on paper in the form of a world with characters in it and places in it and fights in it and so on.
What is this beyond the literature conventional ways of referring that we use in language in my concepts that interplay subtly with language? And
you just have to get used to it. It's the fictional realm. So it's not the realm of lying and being mistaken. People are not mistaken about Sherlock Holmes or Catwoman. They know what they're doing. And they are even maybe when they fall in love with Catwoman, they know what they're doing.
I mean, I would push back on them not being mistaken. I think they can be mistaken about these things, but maybe that's not your point. But I still am not sure what I'm falling in love with, because it seems to me if I'm going to place a hook anywhere, it's the only kind of interface. It's at that point at least the only interface between where I get the information about Catwoman and what I know about Catwoman, which is what I think about Catwoman. That's the target. It's the concepts. It's the things, this whole combination that I'm informed by conventions and I can have conversations about, I can act and behave around, all of which is in my head.
So there are different forms of life, different kinds of activities in which humans engage. There is one activity which is reading fiction. And that activity is in many ways, in fact, I wrote some papers a long time ago on aesthetics. Why do we read fiction? And one of the arguments I considered was that the reason why we read fiction, which is generally speaking a teenager kind of thing, is to experience adult life, and all the dangers of adult life, but without actually endangering oneself. So you read a novel, and then you learn what it's like to be chased by demons, or I don't know. Or what it's like to fall in love. That's why you read a novel. What it's like to fall out of love. That's why you read a novel. And so this is a form of life. Now there is another form of life which involves, I don't know if I want to go down this road.
Oh, please, I'm fascinated.
This other form of life where dirty old men pretend to be beautiful women on the internet and they seduce young girls.
Didn't think that's where this was going.
Now that form of life is fakery. It's not fiction, it's fakery. Fiction is different. Fiction is it's a positive thing, which is a valuable tool to give people a vast realm of experiences in a very safe way.
I'm not sure how that answers the question that I'm posing. So what am I falling in love with? Way of life, way of life aside. Am I falling in love with the life, a way of life? Am I falling in love with the emotions that are elicited when I'm thinking about
I think that kind of the emotion, not falling in love, because that's purely personal, but you might, well, actually, no, I think it would be logically and grammatically correct to say he read War and Peace and he fell in love with the Moscow of 1863. He wanted to
Warm
be.
place in my heart.
Yeah.
Yeah.
So
that's some kind. I think that's a loose way of describing love, but I could form attitudes or relationships to the sort of characterization, historical characterization.
You can relive the experience of 16th century England by reading a novel, for instance.
Just back on this point. I think we both agree, or we both disagree with this.
I agree if you put really rather than real at the top.
Well, I agree with that too. But if you don't, I disagree with it. And I think you do too. So I think we are on the same page.
Suppose now I do not agree with it. They are not real.
That's what
they
I'm saying.
Are fictional, precisely.
But if you put really in, I think you and I both agree that there's some characterization that can be modeled, that makes sense. Whether it's a way of life, whether it's outside the scope of GDCs is a separate question, but I think we can both agree that really.
Okay, so let me summarize what you just said. There is a way of life in which humans behave to each other in various ways. And there is a counterpart way of life in which humans behave with fictional characters in the same way, but in their minds.
I don't know that I mean, yes, interplay.
Okay,
yeah, roughly speaking. Yeah, roughly speaking. And it's a complicated story in both cases.
Good. All right. Next one.
All right. What we got?
4 minutes.
I know.
Do you want to get
Let's
into one
go.
more? Okay.
Yes.
Speed round.
Lightning round. There is no room for non-BFO compliant ontologies in the world's ontology ecosystem.
4 minutes.
I'm happy to take either side.
So you're going to take which?
Which either way.
You take the Dolce side.
Okay. So I'm going to argue that there is room.
Yeah, Italians are allowed.
Are you sure you want me to take this?
Yeah.
I feel like this is the easy side.
Go.
There is room for non-BFO compliant ontologies in the world's ecosystem, as I was discussing last time. Remember when I was discussing IES and BFO and modeling that we're doing across these different representations of the world that have different starting points? One's four-dimensionalist, the other's us. One's more restrictive, the other's us. We're more expressive. And so I think there's room here because I want different perspectives on the world. I want different representations because I might miss something by biasing my architecture to just BFO conformance. As I said, mathematician by training. What did we do? What did we learn? First thing they taught us was translate problems that are really, really challenging into another language and see what happens. This is how Wiles solved Fermat's last theorem, how he understood that there was new math that needed to be created because the old math just wasn't cutting it. I think the same lesson applies here. It's just we need the hardcore formalism as expressive as we can, calling back to our common logic discussion, all the way down from not just BFO from the top to the domains, but also Dolce from the top to the domains. And then we map across them so I can use machines to push a button and flip perspectives on the same data and uncover new information.
So just a few minutes ago, we were pointing out that it would be horrible if the world were subjected to a huge number of expensive ontologies, only a few of which would actually be useful. Now, what can you think of a better way of saving the world from that kind of exorbitant waste?
So non-BFO compliant ontologies I read as those ontologies that may or may not follow, presumably in this case, the ones that we would want would be the ones that follow the same methodology, but have different upper level architectures. So Dolce might not be a good example of this. It's too close to BFO really, but maybe UFO. Maybe UFO is different enough, but it's designed well on best practices if it's made conformant or some new ontology. Maybe Michael Gruninger starts adding actual content to Tupper, right? And does it by best practices, right? According to the sort that we adopt, like, realist inclinations, right? Also methodological convictions like hubs and spokes.
I think that so long as the ontology wars are allowed to continue, the longer it will be before ontology is taken seriously as a...
I think that's true. That's true. But this message that I'm preaching is one that undermines the wars. Dolce doesn't want to fight anymore. Giancarlo doesn't want to fight. He's like, yeah, let's map. Let's build.
I want to fight. So long as they are...
So you want to undermine progress in the ontology community? You're like, so long as there are wars. Oh, that's very Eisenhower.
No, I don't like fighting, so long as the enemy is there.
Well, with that wonderful admission, it's 4:45, and so we'll call the debate to a close, and we'll shift into our closing comments, which
I have what I think is a quick question, and mostly because I'm quite new to ontology.
Okay.
An historical figure like Napoleon in War and Peace clearly was real at the time. Is he still real, or is there some other way to describe him?
He was real, and that's a very high status, but not quite so high as being now real. So past objects, that they are really entities, but they're not currently real.
So would Napoleon be a GDC? Because that was
No, no.
introduction means.
Napoleon is a former object. He has the same status that he always has since he's dead. And before that, he was a living.
Just reading these comments.
Really good.
I mean, somebody's like, common logic's easier than owl. I'm like, you're insane. Yeah, you're just absolute, like, maybe for you, genius, but
Okay, do your wrap up.
okay.
All
Here, do I have any grab this so I can remind me? We are closing out careful modeling today. It's day 2 of the world's ontology ecosystem. And so we've done quite a lot today, right? We had a lot of fun times. I see that everybody in this room looks tired. So we had some modeling exercises, right? We did the unreal pattern stuff, modeling things that aren't real, had wonderful conversations, I think very rich, very glorious about fictional entities, blueprints, simulations. We also listened to fantastic discussion/debates with Barry and a whole host of other folks about the law, very complicated topic, as well as systems after you had some food in your belly. So then we shifted over to exercises, those wonderful exercises, which I have no doubt you didn't finish, which is okay. I told you yesterday they were going to be too hard, and they were too hard. I do want you to think hard about them and keep trying and look at the solutions that I'll post later, and maybe even the videos, and think about the modeling. It is too hard, what I gave you, and I didn't give you enough time to do them. That was on purpose. But you'll get better. You'll get faster if you keep trying. Like I said, I put those exercises and the solutions together in an hour, and I did get the arrows wrong on one of those, so it's not perfect. Nobody's perfect. But it's doable quickly if you understand what the structure is supposed to look like, and you can just kind of see it after a while. And the way you get there is habitual. It's practice, practice, practice. So keep seeing that. Keep doing that. So tomorrow we're going to be shifting away a little bit from that careful modeling, so you won't have to think too hard about topics like that. We'll be talking more about the current AI landscape. How do ontologies and ontology engineering and this tradecraft fit within this larger AI system? So we're going to hear from Barry and Joop Sloan-Craven. They're talking about some of the critical perspectives that we have as ontologists or philosophers in general about the current AI landscape. We're also going to be talking to or listening to Sydney Cohen, who works at INCOSE with us. She's going to be explaining and sharing some of her insights of actually using ontologies and large language models, giving you some practical guidance on, despite the critical failings, how you might take advantage of them anyway, lessons learned sort of topics. We'll also have some exercises where we're focused on evaluating ontology content generated by large language models. And then presumably there will be some sort of debate between Barry and somebody on a call or somebody in the room, or maybe just you. We'll see. Play it by ear. Put debate topics in there, and they'll take advantage of them, and maybe we can discuss that. I will not be here tomorrow, but you will be in very good hands. And this will all lead up, incidentally, to Thursday, this AI topic that is leading up to Thursday, where Jeremy Ravenel will be joining us and talk about some of the hypothesis generation, LLM, ontology governed and driven work that we've been doing on an NIH grant. It will be a lot of fun. You will see some of the ROI you can get from ontology engineering while taking the critical comments and feedback we have about large language models in general seriously. And you will see, you will be able to see some of the return on investment of actually using ontologies and large language models, despite the critical feedback or critical insights that we'll learn from Barry and Joost. We're still able to get something good out of this combination of architectures. You'll be demonstrating that, and you'll be learning how to use it in exercises. I suggested an exercise that kind of starts where some of your modeling has left off so far, where you're taking very challenging axiom-based puzzles and removing axioms so that you can't get deductive solutions out of them, and then using that to feed to a large language models of various sorts and generate best candidate explanations or answers based on fewer axioms. And then you'll start adding axioms, and you'll keep adding axioms until you're able to deductively solve the puzzle. And you hope that the deductive solution is the same one that the large language model gets. We'll see. It'll be an interesting exercise. And then, of course, that'll all lead up to the final showdown between me and Barry about our visions for the future on Friday. I, again, won't be here tomorrow. I may be here for half of Thursday, but again, in good hands with Jeremy, and I'll certainly be here on Friday regardless. And with that, I'll post the videos after this. Well, one of them at least. I got to edit this one. See you tomorrow. Oh, I've got 10 minutes.
So I have a
Barry's got
point.
stuff. I always do this. I land on a great note, stuck the landing, and then
if I look at the screen while you're talking, you're out of.
Oh,
are you going to organize it? I don't know whether this is the case on Tina's machine.
it looks like I am speaking here, like I can, my mouth is moving. Might just be a lag on yours. Here, look, it looks like my mouth is moving in sync with my,
okay,
slightly down. Blah, blah, blah. All right, so I'm told we have.
You got 9 minutes.
We have 9 minutes.
That was a
And
good,
you know, you get what you pay for. And this
in order to have sensible debates tomorrow, now would be a good time to force the people in the room, or even people online, to state suggestions for debate.
We do have a place for them to put debate topics, and I read a couple. We debated at least one of them.
Better to force people on.
Barry is very much a dictator, and so Barry is insisting, and he will find you. He is insisting on you going to the discussion forum for tomorrow. Debate topics ASAP.
What did you always want to know about? It doesn't have to be something that you have a strong view on. You might just want to hear both sides. And you always get both sides very, very clearly and
that's what I do.
Unbiased,
no emotions, robotic almost, as if you could replace me.
I would like to hear a debate with John, maybe taking the perspective of like Denise Fernisa, like advocating for her view.
Oh, I can do it, Denise. Absolutely.
That can't be tomorrow because he won't be here then.
I'll be here Friday. I'll break out my old school cussing.
So there's someone in the chat here making a suggestion.
Uncertainty and ontology. I would like to hear opinions on uncertainty representations. Oh, that's
okay. Yeah, that's a tough one.
I'd be happy to.
But you could write that. Can you write that down as a possible debate topic?
Yeah.
We need to formulate an actual
good
proposal.
They're dropping some hints over here.
Okay.
I'll put it in the chat, but also the capability, how many data sources is too much for an ontology? If you got 5,000 data tables in a large enterprise organization,
is that what you have?
Something like that. That's just data tables, not systems.
But that's not a debate topic. Yeah. That's a question, which is an interesting question.
Debate topic would be like 5,000 is too much. 5,000 is not too much.
So maybe you can give a presentation on what you think the answer is. Or just tell us now.
Really got you
480
there.
You're
going to scare people from giving us debate topics if you do that.
Barry, can you think of anybody that would be able to take the opposite position you take in the book and argue something like AI will eventually be able to do certain things?
Most AI aficionados are bought into the hype, so they all think that AI will next week or next year become
but I mean
clever.
Someone in our
I don't
available
know.
To us.
Do we have any AI?
I'll take it.
You're not going to be here.
Trying to find. I'll take Dario's position. I'll do it.
But you did it already with your refusing to accept that you're irreplaceable.
Oh yeah, all I have to do is
dreaming about powers of AI to replace humans.
Yeah, I just have to hold on tight enough to keep that stock price high. That's all I need to do. I just need to wait you out on the stock price.
No. You're going to lose on that front.
Keep that hype. Get some laughs, see? George's investor.
What about top-down versus bottom-up? How to eject ontology into an organization?
Did you both give a title and the debate topic? I felt like that was a colon.
The debate topic should read something like, this house believes that the top-down approach to ontology is way superior to the bottoms-up. Everyone in the room agrees with that, unless you don't.
The top-down is superior?
Yeah.
We've been going bottom-up for 4 years. We've never even gotten anywhere.
So all we mean when we say top down is you start with BFO.
How many times organizationally?
I mean, introducing it to an organization.
You mean going bottom? You've been going bottom up from the end, like at the work level. And you need to. Oh, that's right. Yeah, absolutely. You should.
Oh.
There's a pincer move you've got to be making. Like you got to go both. It's middle in.
But actually, this does point to a whole area that we probably should attend to, which is how do you deal with establishing ontology in your work environment?
You want to tell them how we do it? You get people at high levels of government hired?
Yeah, that's yeah. So we've been seeding government agencies with the BFO people.
That's true.
And Ryan was there first, but I mean, without our help. But Neil Ott, we seeded him in the APL, and David Limbo at NGI, and there must be a couple of others.
Oh yeah, I mean there are lots all over. The Dutch use that strategy as well.
Who?
Lots of successful organizations.
Okay, well,
Lockheed, Palantir.
So we have a whole program now for producing ontologies, of which you are part. Maybe we'll just send you back.
We need to get promoted.
CEO. I think you probably can replace the CEOs. The back end business guys, the CEO.
So are you the person who is in the Army Procurement University? No,
or not.
That's you. So just explain what your job is.
I've done it for 3 jobs.
What your job title is?
Enterprise taxonomist.
Of?
The Defense Acquisition University, Warfighting Acquisition University.
Okay, that's interesting, isn't it?
It is.
So I told him he has to find out who's teaching taxonomy in that university, and see if he or she knows anything about ontology.
Yeah, we should. Trying to think if I know anybody over there. Maybe. Yes.
This isn't a debate topic, but since we were talking about it.
Yeah.
It would be, do we have like an overview of what that's going to look like?
Check your email.
I'll have a minute to read it.
That's not for you. You already told me.
10-minute presentation or 30.
It's 10 minutes. Did it say that?
Did I really not read well?
Maybe.
But anyway, it should be.
You got your topics.
It should be.
You already told me what you were going to do when we talked about it. It was a surprise for everybody, not you.
It should be N minutes where you talk, and then you should be so provocative that you ignite a really enjoyable discussion.
Also, you should also check we have like a certain allocated amount of time, and there are 14 of you, so you can do math.
Okay.
And the time we have is between 1 and 5.
No,
on Friday.
It's a schedule. Check the schedule.
Depends how much interest you would next.
These people don't read the syllabus. I know. Come on.
Yes.
That was not my fault. That was not my fault. I worked so hard on this one.
So 9:15 to 12, basically.
Okay, so that's quite a long time.
There's just a
Yeah,
little.
but there are 14 of them.
Yeah, but in 2.5 hours, you can do 4 plus 4 plus 2. You can do
I guess
10 talks at 15 minutes.
Signing off. See you tomorrow.
Who are you talking to now?
The people.